Hello, and welcome back to day 2 of NodeConf Remote. We had a great day yesterday with over 3,000 views of the conference in a truly global audience. And today's shaping up to being another great day of learning. So to recap, this is a live event, and this means you'll be able to interact with the conference speakers. And to do that, you can use Slide.io. So Slide.io is Slido. I always say that wrong. You can use that to chat, to interact with polls, and to ask questions. So how does the Q&A work? So if you look to, I think it's this side of your screen, you will see 3 tabs. One of them is Q&A, one of them is chat, and one of them is polls. So if you want to ask a question of a speaker, you put a question in the Q&A tab, and it comes over to me. I will then be able to ask the question on your behalf. So there's no more scary raising your hand and that awkward moment of waiting for the microphone to come to you and then asking the question, is this on? No, it's just me mispronouncing words on your behalf. You can take part in polls. We have a polling feature. And if you've got an idea for a poll, please do get in touch in the chat and put a suggestion in there. The chat, the middle tab, is there for you to talk to each other. Please be nice. We have a code of conduct because everybody here wants you to increase your knowledge and understanding. And we hope that we've created a safe environment for everybody. But if you see a breach of the code of conduct or you personally feel threatened or uncomfortable by anything that has happened in the context of the conference, please speak to Cleaner or Sean, who can be reached on events@nearform.com. We have the code of conduct, which is right down the bottom of this page as well, and you'll be able to see that on the link that's right below the video. If you missed anything yesterday, you can catch up at the NearForm YouTube channel. And in fact, all the talks today will also be up there. We hope you can stay throughout the day. But if you have to go out for something important, like say to vote or something similar, don't worry, we've got you. We will be joined by speakers from across the globe in the next 6 hours. And shortly we'll be joined by Santiago Gimeno, who will be kicking off the conference. So sit back and enjoy NodeConf Remote 2020. Hello, and here we are proving that this really is a live event with me redoing the introduction because we had a little bit of a technical problem before. So welcome back to day 2 of NodeConf Remote. We had a great day yesterday with over 3,000 views of the conference, and it was a truly global audience. And this is shaping up to be another great learning of today. To recap, this is a live event, as I just said, which means you will be able to interact with the conference speakers, and you can use Slido to ask questions, chat, and interact with polls. So how does the Q&A work? What we wanted you to do is to put questions for the speakers in the Q&A tab in Slido. This should be visible at the top of your screen to the right of the video. I get to ask the speakers the questions on your behalf, so you can ask the questions as yourself or anonymously if you prefer. There's no more scary waving your hands or that awkward moment while you're waiting for the microphone to come to you and then asking the question, is this on? Nope, none of that, just me mispronouncing words on your behalf. We have a polling feature, so please do take part in the polls. And if you have an idea for a poll, please put it into the chat. There is also a chat tab in Slido. Please chat to each other and please be nice. We have a code of conduct. Everybody here wants you to increase your knowledge and understanding, and we hope that we've created a safe environment for everyone. But if you see a breach of the code of conduct, or you personally feel threatened or uncomfortable by something that's happened in the context of the conference, please do speak to Cleaner or Sean, who can be reached at events@nearform.com or via the link below this video, which is going to the code of conduct page. If you missed anything yesterday, you can catch up at the NearForm YouTube channel. In fact, all today's talks will be up there as well. And we hope that you can stay throughout the day. But if you've got to go out and do something important today, for example, vote, it's okay, we got you. You'll be able to catch up later. We're going to be joined by speakers from across the globe over the next 6 hours. And right now, we're going to go over to Santiago Gimeno, who will be kicking off the conference. So please welcome Santiago Gimeno. Santiago is a software engineer at NodeSource and a contributor to the Libuv and Node.js projects. Here he is with Uncovering Libuv's Secrets, a Practical Approach. Over to you, Santiago.
Okay. Hello, everyone. I'm Santiago Gimeno, engineer at NodeSource and contributor to the Libuv and Node.js projects. My main objective with this talk is going through parts of the internals in Libuv while showing you some of the work I've been doing to try to add a new backend for Linux based on the new IO Ring API. I divided the talk in 4 parts. On the first part, I'll go quickly through some Libuv basics. Next, I'll make an introduction on what IO Ring is. Then I'll show how I've managed to integrate it into Libuv, and finally I'll show some results at what the next steps might be. So, what's Libuv? As it's widely known, it's a cross-platform support library with a focus on asynchronous input-output. It provides abstractions for network support, timers, file system access, DNS support, and some other functionality. It was originally designed for Node.js, but it's also used by other projects such as Julia, Lubitsch, CMake, and Vine. With regards to the Libuv architecture, everything revolves around its 7-loop implementation, which is tied to a single thread. At this point, I'd like to introduce the event provider definition, which is an OS mechanism used to post execution of the event loop and wait for an event it has been previously registered in the provider. Libuv uses different event providers in order to track input-output activity depending on the underlying operating system. Apple for Linux, KQ for macOS and the BSDs, Event Pulse for the Solaris, IOCP for Windows, and Pol for other Unix flavors. Some operations such as file system access haven't real asynchronous support from the operating system, so they're executed in a separate thread. In the following graphic, we can see the different stages in which the Libuv event loop implementation is divided. We'll first check whether the loop is alive or not, which basically means if there are any active handlers or requests. If not, it will gracefully exit. Otherwise, we'll start a new loop iteration. In the first stage, we'll check if there are timers to be fired and call its callback if so. Then we'll run the pending callbacks, which are specific callbacks for tasks or requests already finished that need to be called in the next iteration of the loop. Then it will go to the idle and prepare handle callbacks, if any. In the input-output phase, we check if the we check for the event provider tracking activity, and this could be either, for example, incoming connections to be accepted, incoming data to be read, etc. And then we'll call any check handle callbacks if any was set, and finally we'll call the close callbacks. Anyway, if you want to check how this is really implemented, I have added a link to the implementation of the UV-run method for the Linuxes, which is very easy to follow and will probably make the things clear. And finally, a brief explanation on how libuv tracks input-output, which is going to come handy later in the talk. There's the UVIoT struct, which represents every input-output resource libuv is tracking. And one other thing is it stores the input-output callback and the file descriptor of the resource. We'll call elements of this type watchers from now on. Then we have the UVIO start and stop method, which add or remove the monitor events on a specific resource. And finally, in the UVIO poll method, the resources are added to the specific event provider for tracking, and also events are retrieved in case already triggered. Moving on now to the IO ring section. So what's this IO ring API? It's a new asynchronous API for Linux introduced in kernel version 5.1 and created by Facebook engineer James Axwell. Its name comes from the use of shared ring buffers for user space kernel communication. The use of these buffers allows to reduce the number of syscalls needed. It also provides some other functionality that may increase the performance even more. But how does it really work? As mentioned before, there are two ring buffers for the user space kernel communication. First is the submission queue, SQ, that is used to submit requests from user space to the kernel. And second, you have the completion queue, CQ, to receive the completion of the submitted request from kernel to user space. The requests for async operations are inserted at the tail of the submission queue, one entry SQE per operation. Then these requests can be submitted to the kernel from where they're consumed from the head of the submission queue. These requests can be batched, as we'll see later, which will allow us to save some syscall. Finally, once the kernel has processed the requests are inserted at the tail of the completion queue, where they can be retrieved from user space. One CQ event, CQE for SQE. The IO ring interface consists of only 3 syscalls. The IO ring setup, we set up both the submission and the completion queues and returns the IO ring file descriptor, which will be used to run subsequent operations on the ring. The IO ring enter, which allows to initiate and complete operations. A single call can both submit and wait for completion. There are a lot of support operations to perform the same functionality as other syscalls already do. Examples include write B, read B, connect, accept, send message, etc. And finally, the IO ring register syscall that is used to register buffers and file descriptors in the kernel, so the kernel can reference them, reducing input-output overhead. But using the syscalls directly on real code is not that simple. For example, in order to set up an IO ring instance, additional mmap calls are needed. So libuv ring is provided to make our life easier, though for most complex cases, the syscalls can still be used there. So now I'm going to show you a very basic example of using IO ring, in which we'll create a socket pair. Then we'll send data from one end to the other, and then we'll close the connection. Notice that the IO ring syscalls are not used directly, but the libuv ring methods are. So in the first section of the code, a pair of sockets of connected sockets are created with the socket pair syscall. Then we'll set up the async rec struct with all the operations we are going to perform in this example. In our case, it will be reading from both sockets and writing to the first one. Finally, we will set up the IO ring instance by calling the IO ring queueInit method, which is a wrapper over the IO ring setup syscall. And in this case, we will set up the submission queue size to 16 elements. Next, I'm going to present how we will be performing the async read and write operations. The idea is going to be always the same. We will first set up the operation in an SQE element, and then we will submit it. Having that in mind, what we do is we first prepare both read operations on both sockets, and then we prepare the write operation on the first socket. A couple of helper functions to read and do write have been created, which basically do the same. So first, we will retrieve an empty SQ element from the submission queue by using the IO ring get SQE method. Then we'll fill the element with the operation we want to submit, whether it's a read or a write. Notice that the arguments set for the SQE are exactly the same as the read via and write via syscalls. And finally, we set the user data field with the async read pointer, which will be passed to the completion element CQE and will allow us to link both the completion with the submission. Then, after creating the 3 requests, we will submit them by using the IO ring submit method, which wraps the IO ring enter syscall. Notice that in order to submit 3 requests, in this case, we only use 1 syscall. And finally, we'll see how to wait and retrieve completion events, CQEs, from the completion queue. What data is stored in those CQEs and how to deal with that. So here's the main loop of the program. It will wait for completions using the IO ring wait CQE function. And when one is available, we retrieve the user data field and cast it to the async request pointer. This pointer has been propagated from the submission request that caused this completion. We then check whether it's a read or a write operation. I'm going to focus only, in this case, on the read completions. So first, in the second socket, we'll retrieve the first completion because we will be receiving data. In the CQ rest field, we will receive the number of bytes we have read, and then we can close the connection. And then I close the connection. So the second completion will be on the other socket, which will detect that the connection has been closed. Notice that CQ rest is 0, and then we close the socket as well. Notice that after handling every completion, the CQ elements have to be marked as free. So they can be reused by the kernel. For that, we use the IO ring CQE sync method. So wrapping up the IO ring section, these are the main benefits IO ring provides. It's a completely async and homogeneous API, even for file system operations. So there's no need to use a separate thread pool. Cheaper syscalls because we just use a bunch of IO ring enter syscalls that need less data copied between user space and the kernel. We can use fewer syscalls. As we saw, we can batch multiple requests in only one IO ring enter syscall. There's even a special mode called submission queue polling, in which the kernel grabs requests directly from the submission queue, avoiding even more IO ring enter syscalls. The problem with this mode at this moment is that, as far as I know, you need to run your program as a super user to use it. I think this restriction will be dropped starting probably in 5.10 or 5.11. And finally, there's some gains you can have by using the registering buffers or files functionality. After this long introduction, let's go to the gist of the talk. How can we integrate this into Libuv? I thought of 2 valid approaches. The first approach would be keep keep using EPOL as the backend provider, but use IO ring for selected operations. This is possible because the ring file descriptor is pullable. There's already a fantastic pull request by Dawson, which shows relevant performance gains by executing file system operations by using the IO ring API, and it avoids using the thread. It's a less intrusive approach, which makes it easier to integrate. The second approach, which is what I've been trying to accomplish, is replacing EPOL with IO ring as the event provider. It's more intrusive as a new full IO ring backend is needed. The main problem I face is that migrating from the current syscalls to IO ring operation is not easy, especially when trying to keep the ABI compatibility. For example, typically a red syscall would return the data in line. On the other hand, with IO ring, that is not always going to be possible. So we are going to need to add some kind of a state to the Libuv handle or request to deal with that. Doing it while keeping ABI compatibility is not straightforward. So as a first step, I set this problem and just use the pull add and pull remove IO ring operations that are akin to the EPOL CTL ops and see how it would go. But first, I like to give a brief reminder on how EPOL is used on Libuv. So EPOL create one is used to in platform loopinit method in order to create the EPOL instance. Then the EPOL CTL method is used to add, remove, or modify file descriptor to be observed by the EPOL instance. It's called whenever a watcher is added or removed from the loop. For example, in the UV IO POL method, the file descriptors from the watchers are added or modified to track specific events. Finally, EPOL wait is used to wait for events or return in case of timeout. The timeout argument is important as we depend on it, among other things, for the timer implementation to work. It can be used in the following ways. If timeout is stopped, EPOL wait will return immediately. This is used in libuv in different cases. For example, if there are not active or active requests of active handles, or if there are any handles, idle handles set up, or if there are any pending or closing handles. Otherwise, for example, if there are no timers, we will set up the timeout to -1. In this case, EPOL wait will wait indefinitely until there is an event. And finally, if the timeout is greater than 0, it will return either on an event happening or if the timeout is there. It is used in the UVI IO POL method to return events from the provider. In the case there are events, we can from the events we can extract the watcher and finally call the watcher callback with the events received. So now, what have been the main modification I had to do to implement the IO ring backend? First, I had to expand the UV loopT struct to hold the IO ring structures. So we define an IO ring data struct that holds the Libuv ring IO ring structure. And we add a pointer to this struct in the loop struct, replacing an unused pointer to maintain ABI compatibility. I've also added a helper method to retrieve this field easily. Also, new methods for the loop initialization release have been implemented. So we have in the platform loop init, the IO ring data struct is allocated, and the IO ring instance is set up with a submission queue size of 4096, which is the maximum allowed by the IO ring API. On the platform loop delete function, where the IO ring instance is destroyed and removed from the loop. Finally, a new UVI POL implementation is also needed. In order to track watchers activity, we'll go through the loop watcher queue and basically perform the same dance we use in the previous example I showed you. We'll first retrieve the empty SQEs from the submission queue. we fill them with a IO ring of Polad operation. And in the user data field, we'll insert a pointer to the watcher, so it's propagated to the completion event. Finally, all the field SQEs will be submitted at once. Next, we'll wait for completions or timeouts in a similar way as we did with equal wait. For this, we're going to use the IO ring wait CQE's Libuv method, which accepts 5 arguments, the important ones being the third, which defines the number of completions before returning, and the fourth, that gives us the possibility of registering IO ring of timeout operation. This timeout operation works in the following way. You pass as arguments the actual timeout value as a timestamp and the number of completions to wait for. So the operation will complete when either the number of completions have occurred or when the timeout is due. In the first case, it will return 0. In the latter, it will return e-time. This way, we can have the same functionality that EPOL provided. If timeout equals -1, the number of waits will be 1 and the timestamp will be null. So the method will wait indefinitely until a new completion happens. If timeout equals 0, the number of waits will be 0 and the timestamp will be null. So it will return immediately whether there are completions or not. Otherwise, if timeout is greater than 0, the number of waits will be 1 and the timestamp will be null. Will be actually set to the actual timeout, and the function will return on either new completions or when the timeout is due. And then finally, we retrieve the completions and call the watcher callbacks. For this, we use the IO ring for each CQE helper, which allows us to loop through the current CQE events available in the completion queue. First, we check if user data is set to Libuv ring udata timeout, which we just ignore because it's the completion of the timeout we have set in the IO ring method. Otherwise, we know it's an event for the watcher, so we cast it into the UBIOT struct. Then we get the events returned from the rest field. This is important. We have to arm the watcher again, as the IO ring of Polad operation works as EPOL one shot. And finally, we call the watcher callback. Then finally, we mark all the retrieved CQEs as free with the IO ring CQE advanced method, which does exactly the same as the IO ring CQE method we had used before, but for multiple CQE entries. So now I'm going to show you the results of my work. So after applying these changes, here are the results. Basically, the Libuv test suite passes. The Libuv benchmark results are quite on par with the EPOL ones, which is probably to be expected because what you may win in syscode optimization, you use it when you have to send the Polad operation after it's complete. But there are some good news I'll show you in a moment. So for the moment, right now, here's a link to a branch where you can play with that code. With regards to the next steps, I like to integrate this work on top of the other pull requests I talk about that implemented the file system operation. Then I like to add as many operations as the IO ring API provides. The main issue being, as I already mentioned, keeping API compatibility. So maybe targeting version 2 is good for the moment to see if it's worth at all. And finally, the good news, I already have a branch adding support for the send message and rec message IO ring operation for UDP handles. And though it's still a work in progress, the results are really promising, especially once the load starts to increase. I include also the GitHub branch, so you can play with that. And now let me show you the actual results. So I'm going to, in the following charts, we're going to see the results of the UDP PAML Libuv benchmarks with 1 UDP senders, 10 senders, 100 senders, and 1,000 senders. The x-axis represents the number of receivers. That means UDP handles receiving traffic. And the y-axis, the number of messages per second. blue for the IO ring backend, and red for the ePOL backend. So we can see that with only one sender, both IO ring and ePOL perform more or less the same. Maybe IO ring a bit better, but nothing significant. But as we increase the number of senders, IO rings start to perform much better. In this case, with 10 senders, we can see a performance increase of about 35%. While with 100 senders, the increase is close to 70% better. And with 1,000 senders, the performance increase goes above 100%. Also notice that with the ePOL implementation doesn't seem to keep up with so much load. As we can see that the performance is worse than we had with 100 sender, while the IO ring seems to do just fine. So as I said, even though this is still a work in progress, it looks very promising, and I'm really looking forward to keep working on it and even add support for other handlers, such as the streaming ones. So that's it from me. I hope you found the talk interesting, and thank you everyone. I can't hear anything.
What is Bloomberg?
Well, I can tell you what it's not.
It's never dull. Bloomberg is
a high-tech,
market-moving, data-driven,
cross-platform
information company,
When we're busy moving the global financial markets,
bringing transparency to business
and helping major players change the
we
world.
go through a lot of coffee.
Yeah.
I like grabbing a free snack with colleagues from other teams and other countries.
It helps me get a fresh perspective.
Well, it's about collaboration.
Across teams?
New ideas can come from anywhere.
Bloomberg is the most inspiring place to work that hasn't been discovered yet.
Wow. Bloomberg supports my volunteer work,
Which is refreshing.
Yeah, and there are many opportunities to give back.
The company is designed to solve global problems,
like climate change.
This is a great place to be if you care about doing good.
We don't think small.
我们拥有超过150个新闻局
in 73 ländern.
世界192箇所にオフィスを持つブルームバーグ
Și în fiecare birou avem toată lumea.
Diversity is essential for business success.
When we're moving this fast,
it's great to know your employer has your back.
The benefits are excellent.
We take that basic nugget of information
from the financial markets
and push it out across all our channels.
Nanoseconds matter.
Faster, but also smarter than anyone else.
And we help people answer questions they didn't even know they had.
It's all about smart speed.
We're passionate about connecting the world
with news,
analytics,
data,
seeing every angle,
with the fastest,
real-time,
borderless,
most caffeinated
organization in the world.
Information is everything.
I see my ideas come to life.
My work really matters.
Did I mention never dull?
What is Bloomberg?
Well, I can tell you what it's not.
It's never dull. Bloomberg
is a high-tech,
market-moving,
data-driven,
cross-platform
information company.
When we're busy moving the global financial markets,
bringing transparency to business
and helping major players change the world.
We go through a lot of coffee.
Yeah.
I like grabbing a free snack with colleagues from other teams and other countries.
It helps me get a fresh perspective.
Well, it's about collaboration.
Across teams?
New ideas can come from anywhere.
Bloomberg is the most inspiring place to work that hasn't been discovered yet.
Wow. Bloomberg supports my volunteer work,
which is refreshing.
Yeah, and there are many opportunities to give back.
The company is designed to solve global problems,
like climate change.
This is a great place to be if you care about doing good.
We don't think small.
我们拥有超过150个新闻局
in 73 ländern.
世界192箇所にオフィスを持つブルームバーグ
Și în fiecare birou avem toată lumea.
Diversity is essential for business success.
When we're moving this fast,
it's great to know your employer has your back.
The benefits are excellent.
We take that basic nugget of information
from the financial markets
and push it out across all our channels.
Nanoseconds matter.
Faster, but also smarter than anyone else.
And we help people answer questions they didn't even know they had.
It's all about smart speed.
We're passionate about connecting the world
with news,
analytics,
data,
seeing every angle,
with the fastest,
real-time,
borderless,
most caffeinated
organization in the world.
Information is everything.
I see my ideas come to life.
My work really matters.
Did I mention never dull?
What is Bloomberg?
Well, I can tell you what it's not.
It's never dull.
Bloomberg is...
Bloomberg is a high-tech,
market-moving, data-driven,
cross-platform
Information company.
When we're busy moving the global financial markets,
Bringing transparency to business.
and helping major players change the
we
world.
go through a lot of
A
coffee.
lot of coffee.
Yeah.
I like grabbing a free snack with colleagues from other teams and other countries.
It helps me get a fresh perspective.
Well, it's about collaboration.
Across teams?
New ideas can come from anywhere.
It's Bloomberg is the most inspiring place to work that hasn't been discovered yet.
Wow. Bloomberg supports my volunteer work.
Which is refreshing.
Yeah, and there are many opportunities to give back.
The company is designed to solve global problems.
Like
climate change.
This is a great place to be if you care about doing good.
We don't think small.
我们拥有超过150个新闻局
In 73 ländern.
世界192か所にオフィスを持つブルームバーグ。
Și în fiecare birou avem toată lumea.
diversity is essential for business success.
When we're moving this fast,
It's great to know your employer has your back.
the benefits are excellent.
We take that basic nugget of information
From the financial markets
And push it out across all our channels.
Nanoseconds matter.
Faster, but also smarter than anyone else.
and we have people answer questions they didn't even know they had.
It's all about smart speed.
We're passionate about connecting the world.
With news, analytics,
Data.
seeing every angle,
With the fastest,
Real time.
borderless.
Most caffeinated.
Organization in the world.
Information is everything.
I see my ideas come to life.
My work really matters. Did I mention never dull?
Welcome back, and a big warm welcome to Joyee Cheung. Based in Zhengzhou in China, Joyee has been involved in Node.js since 2016. She is a member of the Node.js Technical Steering Committee and a V8 committer. She works on the compilers team at Igalia. Today, she's going to give us an insight into how Node.js spends its time in starting up from scratch, and to look at recent changes in the Node.js codebase that have improved the starter performance. So please welcome Joyee Cheung and Node.js startup performance.
Hi, I'm Joyee. Thank you for having me here. In this talk, we're going to take a look at the startup performance of Node, how it evolved, and how we got this far. So a little bit about myself. I am Joyee. I work on the compilers team at Igalia. I am on the Node Technical Steering Committee, and I'm also a V8 committer. In the past year, I have been working on the Startup Performance Initiative in Node. You can find me on GitHub or Twitter via the handle Joyee Cheung. So enough about me. Let's talk about Node. So there had been quite a few issues about the startup performance in Node Core. Take this one, for example. This was opened before we released our recent optimizations of the startup. It used to take around 60 milliseconds to start up Node on a modern Skylake server. So after some refactoring was done and one of the optimization landed, which we are going to talk about in detail later, the startup time on the same server dropped to 21 milliseconds. So the startup was reduced by more than half. Oh, okay. So here is an overview of benchmark results from 3 versions of Node, 10, 14, and 15. This shows the startup time of these binaries in milliseconds. The first group measures the time used to load an empty script, and the second group measures the time used to load a set of public built-in modules shared by all these 3 versions. The numbers are a bit different from the ones described in the previous issue because this comes from the Coffee Lake CPUs, but as you can see, from 10 to 15, we've reduced the load time by around 40 to 50% in both benchmarks. So how did we get this far? This was achieved mainly by using these 3 tricks: refactoring to avoid unnecessary work as startup, implementing code caching, and integrating the VA startup snapshot. So to understand how we use these tricks to improve the startup performance, let's take a look at the Node startup process. So this is an overview of the Node bootstrap. When you type Node from the command line, here are the things that Node is going to do before it can execute your code. So first, we need to do a few setups that should only be done once per process. This includes processing command line flags, setting up signal handlers, initializing the thread pool, and creating the default event loop, and so on. And later, the process is initialized, and one default event loop is created. Then we move on to set up a VA isolate. For people who aren't familiar with the embedded interface of the VA JavaScript engine, VA isolates are the instances of the VA engine. It encapsulates, for example, a JavaScript heap, a microtask queue, pending exceptions, and so on. In Node, the main instance has one VA isolate to execute JavaScript. And if in the process there are workers created using the worker thread module, each of them gets their own VA isolate. So the process and the VA isolate are initialized from the C++ layer. After that, we are ready to execute some built-in JavaScript. For your information, about half of the Node core is written in JavaScript. To use JavaScript for further bootstrapping, we will need to initialize a VA context. So what is a VA context? A VA context is a sandboxed execution context that encapsulates JavaScript built-ins, also called primordials, including global this, array, object, and others. When you call vn.create context from the userland, this is what the return result includes. It is a new context with a different set of built-ins. In Node, userland JavaScript is executed in the main VA context by default, sharing the same context as the one used by the built-ins of Node. To avoid being affected by user modifications of these JavaScript built-ins, we copy the original ones at the beginning of the startup so that the built-in modules of Node always gets to use the authentic JavaScript built-ins. So this is the kind of work that we have to do during the startup. Now we have a V context ready for JavaScript execution. Next, we are going to initialize the JavaScript Node.js environment. To initialize the environment, we first initialize the components that are independent of runtime states. This includes initializing the internal module loader that we use to load one built-in module from another, and most of the globals, including the process object and its properties, buffer, set timeout, clear timeout, most of the web APIs that Node implements, and so on. This is done primarily by running JavaScript, since the internal module loader and the globals are mostly implemented in JavaScript. Okay. Sorry. So after the runtime independent components are initialized, we then move on to initialize the event loop so that we can process the timers and the immediates properly later. Then we'll initialize the VA inspector. We can only start debugging JavaScript, internal or not, after the VA inspector is initialized. And then we initialize the runtime dependent states. During this phase, we configured the environment according to the command line flags and the environment variables that the environment gets. And most of the setup is optional depending on how the environment is configured. We call this phase pre-execution. For example, this is what the initialization of no warnings look like. If the user asks no not to write warnings to STD error, we don't install the warning listener that does this. If the user does not configure no to stop doing this, we'll install the listener. After the pre-execution is done, the Node environment is ready and we can start the execution. We'll select a main script to execute JavaScript. Which script gets chosen depends on how the process is started. For example, if the user passes a file name to Node from the command line as the entry point, we'll load a main script that detects the type of the entry point and loads it with either the CommonJS module loader or the ES module loader. If the instance launched is a worker instance, we'll load a different main script that set up various listeners on the message port and start listening. When the worker thread receives the script from the port, it will compile it and start execution from there. And after the main script is run, we will kick off the event loop and run this until nothing keeps it open. Libuv thread pool will be created if any asynchronous file system operation is used. Okay, now we've looked into the startup process. Let's see how we use these 3 tricks in some phases to reduce the startup time. First, riffing. This is pretty straightforward. For example, a lot of built-in modules depend on each other, so we can lazy load built-ins that are not always used. The downside of doing this is that we will spend more time loading these modules when the user invokes some operation that really requires them. So this was just a temporary thing. We can revert the lazy loading when we can just deserialize them from the startup snapshot, which we're going to talk about later. Another thing that we can do is to avoid unnecessary work like creating the console, which may be a TTY string or a file string, depending on how the process is started. The time we spend on this can be saved using the startup snapshot because, for example, you can snapshot a file handle. So all of this must be done at runtime anyway. So another upside of refactoring is, before it was done, we didn't really have that separation between runtime dependent initialization and runtime independent initialization. These were all intertwined, which made it difficult to integrate the startup snapshot, which needs a state that is runtime independent. So after the refactoring, we have a clean break between these two phases, and we've shrunk each of them a bit. And then there's another trick called caching. As you can see, during the startup, there are a lot of JavaScript that we need to execute. Previously, these all need to be compiled from scratch when you start a node process. And the compilation took a significant amount of time. During 14, we integrated the code cache to speed up the compilation of internal JavaScript modules. Before the integration, we needed to parse and compile the source code of these modules at runtime before executing them to create built-in modules. After the integration, we compile them at build time and serialize the compilation data, which is embedded into the executable. The compilation data contains the bytecode generated from the source code, and with this, the next time we want to execute the same source code, VA can skip a lot of the parsing and compilation process. So at runtime, we can directly deserialize the compilation data from the executable and use them to speed up the compilation of these internal modules. And the third trick that we can do is to integrate the VA startup snapshot into Node. For this, we need the runtime independent state that we can take a snapshot from. As explained earlier, this was done by refactoring and splitting the environment initialization process into two separate phases. After the refactoring, we essentially look at the runtime independent initialization of the context as a whole. We would take a snapshot from the context after these are done at build time, and load the snapshot at runtime. Before we integrated the startup snapshot into Node, we had to run a few scripts in order to initialize the primordials and the globals, including the process object and its properties, and also the buffer constructor and all kinds of web APIs that Node implements. So these scripts would in turn load a bunch of internal modules to complete the setup, and this took time. Now we run the scripts at build time and serialize the internal context into a blob that gets embedded into the Node executable. Then at runtime, instead of executing the scripts, we directly deserialize the result of the previous execution into a which speeds up the startup. This was the CPU profile of the startup process before we before the startup snapshot was integrated into Node. So at phase 1, we initialized the internal module loader for the internal modules to load each other. At phase 2, we initialized the globals. At phase 3, we performed the pre-execution and load the user script. After the startup snapshot was integrated, we no longer need to perform phase 1 or 2 anymore. At the beginning of the startup, we'll just deserialize the snapshot taken after the first 2 phases are completed, which is the gray box on the left. As you can see, this saves us quite some time. So during this journey, we not only improved Node, but also contributed to VA by finding and fixing bugs in the startup snapshot feature. For example, during Node 8, we once disabled the default VA startup snapshot for pure JavaScript built-ins because the hash seed was fixed after the built-ins were deserialized from the context. And this introduced a vulnerability that attackers can use to perform a denial of service attack. You can read more about this in the VA blog post linked here. The solution to this was to generate a new hash seed and rehash all the JavaScript objects deserialized from the snapshot. And this was shipped in Node 8. So this worked fine for a while until we started to customize our own snapshot. And we found out that the rehashing of maps and sets were not supported. This was understandable because VA does not use maps or sets when it creates its own default snapshot. So we went ahead and implemented the rehashing so that we can use these language features in our own snapshot. Another thing that we've been working on is supporting class field initializers in the VA snapshot. As a stage 3 feature, this was once used in our event target implementation, but we later reverted back to using symbols. So one of the reasons was that the class field initializers were not supported in the snapshot. And another was that the initializers are not yet optimized, so they are kind of slowed. You can read more about this in the NearForm article linked here. So after we discovered this bug, we are currently working on the support of class field initializers in the VA startup snapshot. So on the on the side note, we at Igalia also plan to work on the performance optimization of the class fields and power methods sponsored by Bloomberg, so that people can use these language features without worrying about the support issues. Apart from language feature support, we are also planning to provide user-line snapshots in the future. For example, the users may take a snapshot of an application and write it to disk. Then they could either load this snapshot blob from the file system or build it into an executable to speed up the startup of their own applications. This feature may be provided using command line flags or APIs under the worker thread module or the child process module. To follow our work, you can check out this issue in the link. So finally, I want to thank Igalia and Bloomberg for supporting my work, and special thanks to Anna Hennison for her help on the technical side of this project. Thank you for listening.
That was great. Thank you ever so much, Joy.
I've got a couple of questions for you, but just to remind people, if you've got any questions that you would like me to put to Joyee, could you put them in the Q&A tab on Slido? So, Joyee, what is inside the startup snapshot?
Okay, there are two types of startup snapshots. One is the isolate snapshot, which contains like objects that are shared across the VA heap, for example, strings and numbers. Another one is context snapshot, which contains non-primitive JavaScript objects in the heap, like the JavaScript objects that you create. Yeah.
Thank you. Thank you. Okay, so what are the runtime dependent states that you mentioned in your talk?
So the runtime dependent states include states that are configured with command line flags or environment variables. For example, the process dot argv array and the process dot env object. Like obviously, this would be different when you start Node in different ways. So can be included in the snapshot and have to be initialized after we dehydrate Node from the snapshot.
Okay, thank you. So we've got a question here from Nukta, I think. What is the absolute minimum startup time that you think can be reached theoretically, as in sort of napkin math? It doesn't have to be exact, but what do you think could happen?
I think it might be possible to reduce the startup to around 10 milliseconds. I've checked before, like the startup time of Lua and the startup time of Pearl is around 6 to 8 milliseconds on my laptop. Right now, Node is like around 20 milliseconds. So I think there is still room for improvement. But there are a lot of refactoring and like some kind of ICU lazy loading that we need to do on the VA side to make this happen.
Oh, okay. Thank you. I've got it's kind of a comment from Michael Dawson, but looks like the work improved the startup. Did it also decrease the binary size?
I haven't checked actually, but I think it should like increase the binary for like with around like by 1 or 2 megabytes probably. The code cache is not that big, and the snapshot is actually smaller. But like as we implement the userland snapshot, this might be bigger depending on how big the heap of the user application is.
Great. Well, thank you ever so much, Joyee. And it was a great talk. Thank you. And if you've got any more questions, you're on Twitter, aren't you?
Yes.
Brilliant. So you can get in touch there. So we couldn't run NodeConf without NodeConf Remote without our sponsors. So a big thank you to NearForm, Microsoft, Bloomberg, Red Hat, and IBM. Here's a short film from Red Hat now, and after that we'll be back with Thomas Watson. and welcome back. And please give a warm virtual welcome to Thomas Watson. Thomas is a Node.js core member and part of the Node.js security team on the OpenJS Foundation. He's a public speaker and an open source hacker, and he works with the Node.js security team at Elastic, who are also the company behind Elasticsearch, Kibana, and Logstash. He's published hundreds of Node modules, including the excellently named AirCat and Mad Science Project. He knows what's going on behind the scenes in JavaScript with regards to its prototypal inheritance. So here he is to tell you more. Here is Thomas Watson and JavaScript prototypes behind the scheme.
Hey, thanks for having me. Thank you all for tuning in to see me today. As you just heard, I'm Thomas Watson, and I'm going to talk to you about JavaScript prototypes today. And before we get going, I just want to say thank you so much to NodeConf for putting this on in these difficult times. It's really, really nice. So a little bit about me before we get started. My name is Thomas Watson, and I work at Elastic, as Katie said. I will put the slides online later on my GitHub, and you can also reach me at Twitter. So if you have any questions after the Q&A that you didn't get a chance to ask, feel free to ping me on Twitter. So let's jump right in. JavaScript prototypes behind the scenes. So to understand prototypes in JavaScript, I thought we should look at the beginning. So, of course, JavaScript wasn't the first language to use prototypal inheritance. Before JavaScript, or actually the first language that used prototypal inheritance was the language Self. And a lot of other languages came looked at Self and thought, oh, this is a great idea. There is Lua, which is probably one of the most famous ones besides Self. There was IO and a lot of others that you probably haven't heard about. AHK, Order Hotkey. And then, of course, there is JavaScript itself. So JavaScript, when Brent and I created JavaScript famously in 10 days in 1995, he got the inspiration of prototypes from Self. And then he also looked at a scheme, which basically is Lisp. And that's where he got the ideas for functions as first-class citizens in the language. You can see the scheme logo is a function icon. Yeah. So that's kind of the two main ideas of JavaScript came from Self and from Scheme. So of course you're asking the question, classes versus prototypes. What's the big deal? Why do some languages have classes? Why do some languages have prototypes or prototypal inheritance, as you say? To understand that, I thought I wanted to first look a little bit about the classical class inheritance scheme. So imagine your boss comes to you and says, hey, I want to build a UI, I want you to build a UI framework for showing different things. And one of the things it should show is, of course, an image. And you think to yourself, well, images, I know a lot about images. They have a height, they have a width, and of course we need the image itself, so we need some kind of bitmap. So you add that data to the image class. But then later, somebody says, hey, we should also have buttons in this fantastic UI framework. So you think, okay, a button, it has a height, it has a width, it probably has a label with a text, and then it probably has an on-click event handler, so you can do something whenever somebody clicks on it. But the astute of you will probably look at this class diagram and say, hey, wait a second, we have height and width in both classes. That's not good. We're told to never repeat ourselves, right? So let's add a UI element, a parent class that they both inherit from, and move height and width to that parent class, right? So far, so good. But then your boss comes back and says, hey, our clients, they want to be able to click on an image. And you're thinking, okay, well, I guess I can add an on-click event handler to the image as well. So you copy it from button over to image, and now it's 2 places. But you think again, oh, wait a second, we shouldn't repeat ourselves. So let's move it up into the UI element. So you do that. But then, what if somebody wants to create an image that does not know anything about being clicked on? What do you then do? Well, or we could have, let's say, another UI element that do not need to know about being clicked on, right? So maybe you could create a clickable element subtype that then button and image inherit from, but you still have the problem of, well, what if you want an image that can't be clicked on? So the clickable element is more like behavior than inheritance, right? So what you got right here, this is of course a super simplified example, but what you got right here is called the banana and gorilla, banana/gorilla problem. And it goes like this. You wanted a banana, but what you got was a gorilla holding the banana and the entire jungle. It's a quote from Joe Armstrong, the creator of Erlang. And prototypes is a solution to this problem. It's meant as a different way to handle inheritance, where this problem can be solved more or less. So let's look at prototypes. So we're all familiar with JavaScript and Node.js, and the type of prototypes that we think of when we think of JavaScript is probably the type that we can also call the delegate prototypes. So that's the one where we have shared properties and methods, and if you're looking for a property on an object, you don't find it, you go up the prototype chain and look in the parent prototype and so on and so forth. And it's really good for conserving memory, because all the shared properties are only on the prototype and not on each instance of the object. And so when JavaScript was created, Brendan Eich was told, hey, let's create something that actually looks a little bit like Java, so that people, new developers are familiar with it and they can easily learn it. So we got this thing of calling new to make a new instance of an object. And so it's a little bit, it's a Java-esque way of doing object creation. But you can see here a simple cat has a talk function, you call it, and it returns the name. It says, meow, I'm Mr. Whiskas. But this can lead to thinking that, hey, this is just classes and class inheritance in disguise, right? And it's not pure, it's not as pure, like the syntax is not as pure prototypical inheritance as one might want. So actually later somebody thought about this and created the object.create function, which essentially you can do the same thing. You can make your proto object that has a talk function that returns meow and then the name. And then you just object.create with that prototype. You get an object back, and you just put a property on this object called name, and because that's what it expects, and you call the talk function that now exists on the prototype still, and it still works. This works exactly as before. This is a more cleaner prototype way of creating objects, but this way of creating objects never really took hold. This was the idea, but we still kind of use the old new style way of creating objects. But essentially, it's the same thing. So that was the prototypes, the delegate prototype, sorry. But there's also another type of prototypes that we don't really talk about normally, but JavaScript supports it. It's about cloning, it's about concatenation, and it's really good for default state and for mix-ins and stuff like that. So let's, now we're using the new ES5 class syntax, but that's essentially just synthetic sugar on top of the prototypes. It's actually not classes, it's just a different way of writing the same thing. So we have an image as before, it extends from our familiar UI element, and we create a new image. But now we want to make this image clickable. So we just assign a clickable feature to it using object.assign. So now this image that we created is clickable. And in the clickable object, of course, there is all the information that JavaScript needs to know about how to make something clickable, right? So that's the two types of prototypes. So I thought, basically, with that out of the way, let's get our hands dirty. Let's look at some code. So if we fire up a node REPL here, so consider that we have an object, just a standard object. So on this object, we can call has own property X. We get false back. So it begs the question, where does the function has own property come from? We just created an empty object, right? And we're calling a function on this object. Of course, you probably all know the answer to this, but let's try to dive a little bit in. Let's look at the object. It's empty, just as we created it. Nothing there. So where is this coming from? So there is on the object. There is the getOwnProperty descriptors function that we can use to see things that might not be enumerable. It could be that hasOwnProperty is just not enumerable, right? So it's not showing up when we just look at the object by default. And as we see here, nothing either. There is no properties whatsoever, not even hidden ones. So whenever we access an object, anything on an object, be it a function or a property, JavaScript will first look if the property is on the object, and if it is, we'll use that. If not, it will look at the prototype for the object and see if the property is located there, and so on. So let's try to pretend we are the JavaScript engine. Let's try to manually do this. So let's get the prototype, of object, and let's try to get own property descriptors of the prototypes. Now we just have the prototype in a variable. And let's just use the right function here. We need an S at the end. There we go. As you can see, there's a bunch of prototypes. A bunch of properties on the prototype. And actually, right now, of course, so the variable that we have is just object.prototype, right? So it's just the brute prototype. And all objects will by default have object.prototype as their direct prototype, i.e. they will inherit from object prototype. And besides using object.getPrototype off, as we just did, to get the prototype of an object, for historical reasons, there's also a magic property called __proto__. It's now deprecated, but it's still there. It can never be removed. But you probably stumble upon this in the wild as well. So, but __proto isn't a property on each object, as we just saw. It's not there. Instead, it's actually a getter/setter property on object prototype. You can see right here in the screen. And it's simply behind the scenes. What it's actually doing is actually using object.getPrototype off and in the getter form. And for the setter, it's using object.setPrototype off. So the following two forms are essentially equivalent. We can take the object and we can give it a new prototype. So if I can spell, there we go, by doing like this. Or we can say object set prototype of object obj, and then an empty object. Those two are essentially the same thing. So note that it's also possible to set the prototype of an object to null. This way, the object doesn't inherit anything, even from object prototype. This is essentially what the type of object prototype is, because object prototype is also an object, right? So the prototype of object prototype is null. So that means that's the end of the inheritance tree. So far, I haven't explained the meaning behind the prototype property on object is. We only discussed the special __proto. So let's dive a little further in and look at the properties of a newly created function. So we have let's make a function called pet, and let's look at the property descriptors of the pet function. You see it has a couple. And notice there is a prototype property, and it's just set to an empty object. All functions has a prototype property. And whenever we use a new keyword in JavaScript together with a function, the following happens. One, a new empty object is created. Its internal prototype reference is set to point to, in this case, pet.prototype, this empty object. And this makes the act of setting the internal prototype reference to this prototype object makes it an instance of pet. So if it's set to pet the prototype, then it becomes an instance of pet. So now, if we do obj equal to pet, now obj instance of pet true. So the second thing, the third thing that happens is that the pet function is called with this being set to the new empty object that was just created. So that's essentially the same as saying pet.call and then object and then whatever arguments that you want to give it, right? So let's try to create a cat. And cat is now instance of pet, right? Yeah. Let's look if the prototype is as we expect. It is. Okay. Slight diversion. For fun, let's try to just get property descriptors of an arrow function. An arrow function here. Notice that it doesn't have a prototype property. Why is that? So all arrow functions, they can never be used as constructor functions. You can't have a new in front of it. So hence they can't be, so there's no need for the prototype property, right? Okay, anyway, let's go back to the case at hand here. Let's try to set the age of our cat to 42. And okay, now the cat is 42 years old, pretty old cat. Let's try to concat the age here. And let's look at age again. It's now 43. So, but what is pet.prototype.age? That's still 42. So why is that? Essentially, that's because when you plussed the age, what we actually did was cat.age equal cat.age plus 1, right? So first it's looking at cat.age. It's not finding it, so it's getting it from the prototype. Oh, it's 42 on the prototype, plus 1, that's 43, and then assigning that to cat.age. Is cat.age on the cat object? Oh, no, it is. Well, it creates it. It creates it. So now it's created a new age property on the cat that has the value of 43. Obviously, this only works with simple types like numbers and strings. If we were to have the added prototype name first, like this, and then say cat name first equal to hello and fast equal to kitty. Now the pet prototype name is basically polluted. So don't do it like that. But what about object.prototype? We just were told that all functions have this prototype property. This essentially means that object that we know with an uppercase O must be a function, right? So it means we must be able to do new object. And we get a new object. So writing curly brackets like this is essentially just a shorthand of writing a new object. So all functions have this special prototype property, and they will all be initialized to an empty object, even if they never intend, even if we never use them as a constructor for anything. So it's just there just in case. So let's look a little closer at functions. Is a function something special, or is a function just an object? So we have the pet function and the instance of object. Yes, it is. So a function is also just an object. That must mean that pet must also have a __ proto property. It does. But what is it set to? Well, it's set to the function.prototype. So what does function prototype contain? So it contains all the functions and stuff that we're used to to be able to expect on functions like apply and bind and call and all that stuff. But it can often be confusing that there's both an __ proto and a prototype property. But think of the prototype property as an inheritance blueprint only to be used when the function is used with the keyword new. The naming, of course, can be quite confusing because it's not the function's prototype, even though that is what the property spells. Instead, it's, I don't know, I want to call it the prototype template or the prototype blueprint, but those names are not the best either. So yeah, but that's why it can be very confusing. But I have to confess, I've been lying to you. The prototype object automatically created on all functions isn't entirely empty. Let's examine it. Let's create a new function here. Object get own property descriptors fn.prototype, and we're missing the s. There we go. So it actually has a constructor property. So this is set to point to the function itself. And this in turn means that all objects also have a reference to the function that created it. So we can say cat.constructor == pet. And we also, and since we know that object is a function, it must mean that we can do like this. So back to the slides. So this is, of course, all can be very confusing. I know. It is for me, at least. I don't know if it is for you, but it is for me. So to help myself out, I created this diagram to show all the interactions, how things are pointing to each other. So in the bottom right, we have a new empty object. And you can see it has a proto reference to the object prototype. It's dotted, which means that it doesn't actually have it. It's inherited. It doesn't have that __ proto as a property. It's just inherited. And the same goes with the constructor. It's just inherited. And of course, it's inherited from object prototype. So it's pointing to itself, and it's inherited from object prototype, right? And you can also see that object prototype has doesn't have a null prototype, right? Okay, so what if you have multiple object inheritance? So you have an object that inherits from another object that then inherits from object prototype. It looks like this. So we've set a custom prototype to the bottom object there. And what if we create a new function? It looks like this. As I said before, I'll share my slides afterwards so you can get access to these diagrams. They are super, super handy to have when you're debugging things or wanting to understand prototypes better. So finally, I thought I wanted to talk to you about prototype pollution. So to talk about prototype pollution, let's look at a common source of pollution. And I'll get to what prototype pollution means and all that via this example. So we have a merge function. It takes a target and a source argument, and it takes all the properties from the source arguments and copy it to the target object by looping over them using object.entries. So if we call merge with two objects that has A and B, we get the expected result. And if we do the same with where both have a called A and they have different objects inside them, we don't necessarily get the result that we want. Notice how it's just using the last value of A and overwrites the first value of A. So how do we deal with this? Well, we make a deep merge function. Essentially, it's doing the same thing as before, except when it gets a new value, it just checks if this value is an object. And if it is an object, it just clones it by calling itself. So we have a copy of it, because we don't want to make changes to the source. And then it checks if this property also exists on the target. And if it does, it calls itself recursively. So now we have a deep clone of the objects. And if we try to call deep merge with our two objects from before, we get the expected result. Okay, so how can this be abused? Let's say you have a function in your application that says isAdmin, takes a user and checks if the user has an admin property equal to true. You create a new user, you give that user to the function, it returns false. The user is an admin. But then let's say somewhere else in the application, you are receiving some JSON data from the client, and that JSON data just happens to have a JSON property called __proto that says that admin is true. If we give that to our deep merge function at some point, well, what will happen is that it will actually set admin on the object prototype, and which means that all objects in our entire running Node.js application will now have admin equals true. So what's the antidote for this? The antidote is, well, look out for __proto in untrusted user input. If you have a JSON string, you can potentially search for it, though you have to look out for Unicode characters, stuff like that. However, you would think that was it. You also have to look out for any references to constructor that then references prototype. So why is that? Isn't __proto the only thing we need to watch out for? Well, it turns out that if you follow the constructor property on an object and then follow that prototype property, you get to the exact same place as if you just followed the __proto. So you get to the object prototype, and that way you can pollute the global scope of your application, which of course is something you do not want. So both of these is something that you need to watch out for. And doing this, of course, can be, let's just say, pretty complicated. If you want to save yourself some trouble, if you're passing JSON and you want to make sure that this JSON doesn't contain any of this, there is a different way to pass it. You can use, instead of JSON.pass, you can use secured JSON pass, which basically takes care of this for you. And you, by the way, you might say, well, I'm not using any deep merge function anywhere. The deep merge function was just an example, of course, and this exact problem of this deep merge function was actually a problem in Lodash not that long ago. So certain versions of Lodash today is vulnerable to this problem. So it actually happens more than you would expect. And of course, the last antidote is constant vigilance. Thank you very much. It's been a pleasure presenting to you. Yeah. Over to you, Katie.
That was very, very insightful, and thank you for promising to share those incredibly helpful diagrams. I've got a couple of questions for you. First off, John asks, when you set the first and last name of the cat, why did the prototype variables of pet change?
Good question. Yeah, I glossed over that maybe a bit too quickly in the to save time. But so when you say cat.name, the moment you do that, cat.name is not a property on the cat object. So it will just look up the prototype, say, oh, there is a name on the prototype of the and it will access that. And the moment you then say something else, for example, .first, now you're actually inside the object that exists on the prototype. So when you then assign hello to first, you're actually assigning to the first property of the name object on the prototype. I hope that makes sense.
Yeah, thank you. How can leveraging the prototypal inheritance help your code to perform better?
Yes, so prototypal inheritance is used by V8, in this case of Node.js, V8, the JavaScript engine behind Node, does a lot of tricks to optimize your code to perform better. And one thing it does is it recognizes object structures. It's called hidden classes. It recognizes object structures that are used again and again and again. So we made a lot of instances of cat. It will simply reuse that, and it will just have it will basically mean that it doesn't have to recompile the new objects over and over again to access the same functions. That's like the very brief short answer. So it means that the code is faster.
Okay, great. Thank you, Thomas. I know there's a couple more questions, but we are going to have to move on because we've got to keep the conference going. You are available on Twitter, though, aren't you?
I am, yes.
So yeah, please do reach out to Thomas on Twitter if you've got any questions that you feel he can answer. Thank you very much. And I think now we are going to a short break. Please do stick around because later today we've got talks from, amongst others, modern JavaScript inheritances, packaging, cross-platform Node.js binaries, and automated tests in microservices. So right now, go off, get yourself a cup of tea or coffee, get yourself some biscuits or cake. We'll be back in 10 minutes or so with Maël Nison, and see you soon. Hello and welcome back. I hope you've had a good break. You join me now for our talk with Maël Nison. As you're probably aware of Maël's work through his work in Facebook, where he has been building innovative infrastructures designed to empower thousands of JavaScript developers, including work on the JavaScript package management tool Yarn. Maël now works at Datadog, but he continues to have oversight of the development of Yarn, whilst also building tools that target developers. During his free time, he also likes to bake pancakes. So please put your virtual hands together for Maël Nison with modern JavaScript infrastructures.
Thanks, Katie. Hi, everyone. So today we're going to talk a bit about modern JavaScript infrastructure, what it means, and how we do this. So as I said, we're going to talk about what it is and why it doesn't matter. We're going to go over a few important features in front-end infrastructure, and then we'll go over some general tips on how to be efficient in improving an infrastructure. So first, what is front-end infrastructure? The infrastructure term is usually associated backend, so it might surprise to hear it in the context of infrastructure is defined by the components providing commodities and services essential to enable, sustain, or enhance one's condition. There is nothing that is strictly related to the backend. So in the context of front-end, infrastructure means that instead of having the build being an afterthought that you delegate to the product team every once in a while, where someone says, oh no, the build takes too much time, we have to do something, you will instead have a team that will be in charge of focusing on the developer, on the stability, so that all your developers can be free of working on the product at the core of your application. By doing this mission, they will optimize workflow and make everyone more productive. The reason you should consider maybe having a team or at least one or two people focusing on this task is that it makes your teams be able to focus on the product itself. So it gives a better separation of concerns. And by doing that, it leads to shorter development cycles and faster iterations because, as I said, your product team can really be laser focused on the part of the product that they are expert into. Many companies have front-end teams. So, for example, Pinterest had people working on improving the build times. Shopify also has people working on improving the merge queue, and of course, Datadog has people working on their infrastructure as well, since I work there. The idea is that really, instead of having to break out of your quarter chaos in order to suddenly fix something inside the build or make an upgrade that you didn't anticipate, you will instead be able to delegate all those tasks to one people that will be able to give a long-term roadmap on everything related to the infra. So when we are working on infrastructure, there are a lot of points that we are very aware of and that we look into first thing when starting to work on a new project. The first one are previews. So the idea is that in order to make a good product feature, you need to develop it locally. And so in order to do that, you typically use something with a node loader so that when you make change, they can be seen immediately. But the question arises, what happens once you have finished your feature and push it on GitHub inside a pull request? Because the people that will be reviewing your work will read the code, but they will also need to see the code in practice. Without PR, they would have to check out your code, then run the builds, and then see on their laptops. It means that there is a very heavy cost in terms of context switch. Previews are a way to just let your team share their changes without having to make checkouts, just by pre-compiling your branches and showing them through special URLs. A lot of providers do this by default, like Netlify, Gatsby, or Virtual, but it's actually very easy to implement even manually. So for example, at Datadog, that's what we do. We have a GitHub action that is building our front end for each PR so that anyone can access any PR and see it live. Another thing to look for in infra are monorepos. So why monorepos and what are monorepos for those who are not super into that? So monorepos are a way to split your application from a single directory containing a bunch of sources into many directories with less sources. So for example, here on screen, you have the example of the yarn codebase that has been split into multiple directories. Then each of those directories can have a separate dependencies field that lists all the dependency that affects this folder and the dependencies to other workspaces. So for example, here you can see that the package fslib has a dependency on another workspace, the libzip, and by this means it will be able to use the sources directly from the repository instead of fetching them through a registry as it usually does. Monorepos are great for library, but they are also very good for private apps because even if you're not publishing the packages, they allow you to keep your dependencies close from whatever are actually using them. So for example, if we go back to the example I was showing, in this package.json, you see that the fslib only has a dependency on tslib. So if we didn't have workspaces, we would instead have a single package.json that would contain 300 dependencies, but with no context as to what is using them. Additionally, monorepos and workspaces force developers to be very intentional about introducing cross-dependencies into the application. So that's always a good thing, even at the moment of review, because it means that you clearly see whether someone is adding a cross-dependency to a package that is probably semantically wrong, so that you can surface this and discuss it at review time. And finally, they also are a very neat way to define ownership of the application, since workspaces allow you to split your application. So it's just one step further. You can have a code owner file that is covering specific directories, and it's much more clear who is working on which part of the application. When using monorepos, we recommend to use yarn over npm, even 7, because even if npm 7 now supports workspaces, they are still a bit young, whereas yarn has had years to work on them. Yarn 2 also replaces Lerna advantageously, so we have a lot of features that have been first tried by Lerna and that we decided to implement by default. For example, the Babel repository is now using Yarn 2 because of the commands like yarn workspaces for each. And if you're trying to get an idea of a very good monorepo example, you can actually look at the Yarn codebase, which is a very big monorepo, as I mentioned, that is using a lot of very modern techniques like in-sources file access. So it's a very good example if you want to see what is actually possible when using a monorepo. Text editors are also an area of choice when working on architecture, because when you think about it, where do you spend the most of your time when working? The answer usually is in front of an editor. It can be in front of an editor because you're writing code, but more often it will be because you're reading code or because you're reviewing code, which is the same as reading, really. So by being aware of the editors, maybe not all of them, but at least the main one in your company, you're able to build company-wide integrations like the VS Code tasks, which allow you to define a set of named tasks that people can just access through the command menu, or to apply settings to everyone in your organization. That's very important because as you start onboarding more and more people, you don't really want them to have different experience in terms of linting, because otherwise they will have to fix the linting once it reaches CI, or they will be frustrated because they don't understand why things are different. So you want a uniform experience, and by having some control on the editor configuration, it's much easier to reach that. One very simple thing that you can do is to add an editor config file, which is supported by most text editors nowadays, that ensures that, for example, the same indent level is used for everyone in the company. But on a larger scale, you can do this with linting, you can do this with prettifying, you can do this with TypeScript, a lot of areas of improvements. Speaking of CI workflows, those are one area where you can do a lot of things, especially now that every provider is now having scheduled tasks. So first, you can, of course, run regular test suits as a merge blocker, so that a PR cannot be merged unless the test suit is passing. But you can go further. For example, you can have a set of expensive end-to-end tests run as scheduled tasks. For instance, let's say that you want to run tests on all browsers. It would be very expensive to do that on each and every PR. So instead, what you can do, if those tests are usually passing, is that you will run them on your master branch every hour or so as a scheduled task. You can go further in your workflows. For example, in Yarn, we are running actual benchmarks every 3 or 4 hours against all our competitors. So we are running Yarn install, we are running npm install, we are running pnpm install, and all that is then sent directly into a Datadog dashboard. So I have some rough idea of how we fare compared to the competition. And spoiler alert, it's pretty good. There are also a lot of tasks that you can do using workflows, even some that are a bit more exotic. So one other workflow that we have inside the Yarn repository is that each time you're opening an issue as a bug, we have a bot that will try to run your reproduction inside the issue on a virtual machine. And if all the tests are passing, then it will tell you that there is something wrong in your reproduction because we can't reproduce it. And by doing this, it means that we are shortening the time to fix a bug because we don't have to make the dance of, oh, but I can't reproduce your problem. Can you share more details? Instead, reporters can just know immediately that what they shared is not enough and try to investigate in order to provide all the information that we will need to fix the problem. In company settings, you can instead make auto fix for linting. Same thing by implementing an action that would trigger each time a commit is sent on a PR. There are a lot of options for CI workflows. So don't just stay on CI workflows or for testers, because there's a lot of actions that you can do that are more complex than that. Speaking of CI workflows, one thing that I've noticed is very important on each infra is to avoid relying on the network. So a lot of people are doing something like yarn install inside their project, inside their CI. You should really avoid doing this because as long as you rely on a registry, even one that is as famous as NPM or GitHub or anything, you will eventually reach a state where you cannot deploy because the network is down. So it might be your network, it might be your proxy that is doing something different, it might be the remote registry that is down and you cannot deploy. You should not rely on the network. That's critical. You have a lot of tools in order not to have to do this. With Yarn 1, you have these settings called Yarn Offline Mirror that allows you to store all your packages inside a specific directory so that you can check it out inside your repository. And instead of downloading them from the internet, Yarn is then able to reuse them directly from where you store them. With Yarn 2, it's a default that you can disable if you don't like that, but it's there if you need it. And if you have NPM or PNPM, you can use Verdacio, which is a proxy for NPM that catches all the packages that you're downloading and store them somewhere so that you can just reuse them instead of querying the actual network. Any of those options is great, but the point is that you really not should rely on the network because it is very flaky. If we go one step further, if you store the packages inside your repository, then the question that we can start asking is, why does it matter to run yarn install? Is it actually a good thing that we have to run yarn install? No, it's a byproduct of how things work. But usually what I do is that I work on multiple features, and I'm sure you're doing too. And each time I was switching from one feature to another, I had to run yarn install in order to make sure that my dependencies were updated. Each time I was pulling from the remote registry, I had to run yarn install again to make sure that all the dependencies were updated. And if I would fail to do that, then there were a risk that my application would not work. And then I would have to figure out whether it's my problem, my diff that is introducing a problem, if it's just that I didn't run yarn install and some dependency is broken. Clone and Go is a change in this aspect, in that starting with Yarn 2, we don't really want you to have to run yarn install when switching branches. So we want to give you the tools to avoid that. It's a new workflow, That means that you can now switch between a repository's branches without having to run yarn install. It's much easier to make context switches, and it's very important because it unlocks a lot of new capabilities. For instance, here on screen you have the GitHub extension for VS Code, and inside this extension you have a right-click menu that allows you to check out a pull request. Even though it's nice, in a typical setup, it's problematic because you still need to update your dependencies. If you don't, things might break. And even if the application was to make this automatically, install still takes some time, so it would be a subpar developer experience. But with Clone & Go, you just have to click the Checkout Pull Request button, and suddenly your application is ready to be modified without you having to do anything, and it's super fast. So how does it work? It's just that in this repository, so in this case, it's the yarn repository, we store all the package tarballs inside the repository, similar to what I mentioned about offline installs. And by doing this, there is nothing else that we really need. Everything is there. We can just run any application we want without having to run installs. So it's really nice, and you should check it out. It's hard to really understand how impactful this is in the workflow until you've tried it, and then you understand that, whoa, why doesn't it work like this always? The idea, basically, is that fast installs are good, but it still means that you need to run an install, and we don't want to run an install because installs are slow and installs are unpredictable. Something might break during an install. It's much better to have no more installs at all inside your workflows. Changing subjects, full type coverage are also very important in terms of infrastructure. I know what you're thinking. Your application might already be using TypeScript or Flow for their sources on the product. But is it also the case for scripts? Because your build scripts are very important too. And it's maybe even more important because they are the foundation upon which all your product is built. So if your build scripts are not covered by TypeScript, it means that they will be extremely difficult to understand for any new people joining your infra. And that even if you are making a change, there is a high chance that you will forget something and that something will break. Nowadays, it's very easy to type your build scripts, your Node scripts, just by using Babel Register or TS Node, which will allow you to run your scripts as a TypeScript without even having to make a transpilation. You don't need dnode to do this. You just have to use Babel Register or TS Node. So I really recommend to spend some time into making sure that all your scripts are covered by TypeScript so that you're making the job much easier for everyone to understand what happens in your foundation layer. Internal integration are the last topic that we are going to discuss as far as features goes, and it's the most open-ended one. So the idea is that as your company grew, you will have more and more workflows of more and more tools that will interlace together. For instance, you might have a Circle CI job that you will go trigger a Jenkins job that will be based on the tags created on GitHub. You have a lot of different pieces that are merging together. But it's sometimes difficult, especially when you join a company, to know what are those workflows and to understand them. And the question arises, why do we have to understand them? And something that is very good in order to prevent the problems from arising because of too much complexity on your workflows is to abstract them behind a simple interface. For example, it might be just an interface that shows you all your deployments without you having to jump on GitHub in order to get the commit hash and generate the link. It might just be something that does use the GitHub API in order to fetch all those information and print them on a single page. The point is, abstract all workflows behind custom integration in a way that will allow you to simplify those workflows as much as you can. For instance, that's a kind of integration that is aware of what we do in our company. So at Datadog, we have an extension called Dogo that is able to inject some code into some websites in order to add some Datadog-specific context information. So in this case, you can see that the merge button on GitHub got turned into blue because it's code freeze season. And when it's cut-free season, developers will be able to know that it's not the right time to merge just by going on the pull request interface. Otherwise, they would have to go on Slack in order to see, is it cut-free season? Oh, I forgot I already merged. So this prevents a whole set of problems by making the information directly available to the engineers without them having to search for them. We have other integrations. So for example, here we have the type check that is simply running a TypeScript daemon in the background and querying it from WebSockets. By doing this, we have more abilities to track which are the problems inside the code base, but also print them in a format that is much easier to consume by our developers. There are a lot of things that we could still discuss regarding front-end infrastructure. For example, there would be the security aspect of it that we could abort with Snyk. There are the maintenance of it, when you need to upgrade one package from one version to the other, when you need to investigate whether ES build is wall-to-wall, when switching from Webpack 5 to 4 to Webpack 5. We could talk about how to make efficient open source contributions, because when you work on infrastructure, you ought to make contributions to third-party projects in order to fix bugs or implement features that would make sense for your use case. We could do all that, but it's just a 25 minutes talk, so we will have to switch to the next part, which is the arsenal that you have when working inside an infra team in order to be efficient. The problem of infra is that it's very hard. You rarely get a product manager gathering feedback for you. You need to do this by yourself. You need to go to your teams and ask them, hey, what is painful for you when working on the product? And you will find that there are a lot of things that you can do in order to improve the experience of all developers in the company. So it's important to figure out a process to do so efficiently and to prioritize the tasks that you will be working on based on a lot of criteria. And in order to figure out what are the main tasks that you should work on, there are one important way, which is to communicate a lot. There are 3 feedback channels that you should use when working in infra in order to be sure that what you're working on will be impactful for your teams and that you are improving things on the long term. There are the mixed feedback, the active feedback channel, and the passive channel. The mixed channel means that you need to make yourself available and be a clear owner. People inside your company need to know that, oh, there is a problem, I need to go see Maël in order to fix it. The active channel means that you need to sync periodically with the teams to make one-one with engineers in order to gather intelligence about what is wrong in their workflows, in order to know whether what they are doing is subpar, and also in order to let them know what you are working on, because maybe in these settings, they will tell you, oh, but build time is not actually a problem. I mean, it's fast enough for me that I don't feel the burden of the time it takes to make a build, for example. And the passive channel is very important too, and means that you need to have a way to gather metrics, accurate metrics, and track their evolution over time. One trick about this is that metrics are not the most important thing about front-end, about infrastructure in general. It's easy to gather metrics, for example, let's say the build time, and to see, oh, the build time is at this level. I want to improve this and make it twice as fast. And that would be great. The problem is that by doing this, you didn't validate first whether it's actually impactful for the team. So as I mentioned in the active channel, it's important to go to the team in order to validate that the metric actually makes sense, because maybe it's just a number and making it lower will not have enough value on engineers. So in terms of metrics, what we are doing at Datadog is that we are having a hook on the yarn run command so that we can know how much time take all of the scripts that are running inside the repository. So for example, here we can get a pretty good idea of the number of type checks that are running inside the company and the time it takes in order to run them. By doing this, when we are working on improving type check time, for example, we can see that, oh yeah, the number is actually decreasing. So it's not just something like, oh, I run this locally and it seems to have a good effect, we can actually rely on practical numbers in order to know that what we are working on is having effects. So as I mentioned, you need to use all channels in order to be effective. You need to use the mixed channel for transparency so that everyone is aware of what is going on and that everyone knows that they can come to you if they have feedback about it. You need to use the active channel in order to plan ahead by asking directly to the first people that will be impacted by your changes what are the problems that they would like to see solved, and by using the passive channels in order to track your success over time. So it's really an endless cycle of interpreting data, then validating them, then tracking their evolution over time. So in conclusion, in order to succeed at infra, you need to plan your work long-term while still staying flexible. You need to communicate early with the teams, and you need to communicate often. A lot. Communication is really key in this kind of context. And you need to make sure that everyone is on the same page. And you need to do it twice because it's likely that people will have ideas about how to fix things. And you will need to really be very clear about what will be the changes and why to do this and how things are going to work. You need to have everyone agree on clear owners so that you still have the ability to make the changes that are good, but you need really to make sure that everyone knows what's happening. I hope that gives you a quick overview of infrastructure. And if you have any other questions, feel free to ping me. It's really an amazingly interesting topic because you're working not only for a product inside your company, but also for your colleagues by improving their daily work. And it feels good to be very close from them in order to know what are their pains. Thank you for your time.
Thank you, Maël. That was absolutely fascinating. And as somebody who used to work on infrastructure teams in the BBC, it rings so very, very true. And I would love to talk to you for ages about this, but unfortunately, we have no time for questions for this one. But if people have questions for you, can they contact you on Twitter?
Sure. I would be happy to answer.
Thank you so much. And thank you again for your excellent talk. So yes, sadly we have to keep the conference moving because we have an excellent talk up next as well. So we have Irina Shestak coming up. But before then, we have a word from our sponsors, IBM. So see you soon.
Hello, I'd like to take a moment to talk to you about what it means to be open. IBM is open. IBM's cloud is open. What does it mean to be open? It means to be driving innovation in cloud technologies that underpin the power of cloud. IBM has over 25 years of history of contribution with open source, including Linux, Apache, and Eclipse foundations. At IBM, we believe the power of open source is in the community that surrounds an open project. When developers and even companies from different backgrounds, ethnicities, varied training histories, unique perspectives collaborate around making a technology, the result is that the code is richer, more secure, and more innovative. Hello, I'd like to take a moment to talk to you about what it means to be open. IBM is open. IBM's cloud is open. What does it mean to be open? It means to be driving innovation in cloud technologies that underpin the power of cloud. IBM has over 25 years of history of contribution with open source, including the Linux, Apache, and Eclipse foundations. At IBM, we believe the power of open source is in the community that surrounds an open project. When developers and even companies from different backgrounds, ethnicities, varied training histories, unique perspectives collaborate around making a technology, the result is that the code is richer, more secure, and more innovative. Hello, I'd like to take a moment to talk to you about what it means to be open. IBM is open. IBM's cloud is open. What does it mean to be open? It means to be driving innovation in cloud technologies that underpin the power of cloud. IBM has over 25 years of history of contribution with open source, including the Linux, Apache, and Eclipse foundations. At IBM, we believe the power of open source is in the community that surrounds an open project. When developers and even companies from different backgrounds, ethnicities, varied training histories, unique perspectives collaborate around making a technology, the result is that the code is richer, more secure, and more innovative. Hello, I'd like to take a moment to talk to you about what it means to be open. IBM is open. IBM's cloud is open. What does it mean to be open? It means to be driving innovation in cloud technologies that underpin the power of cloud. IBM has over 25 years of history of contribution with open source, including the Linux, Apache, and Eclipse foundations. At IBM, we believe the power of open source is in the community that surrounds an open project. When developers and even companies from different backgrounds, ethnicities, varied training histories, unique perspectives collaborate around making a technology, the result is that the code is richer, more secure, and more innovative. Hello, I'd like to take a moment to talk to you about what it means to be open. IBM is open. IBM's cloud is open. What does it mean to be open? It means to be driving innovation in cloud technologies that underpin the power of cloud. IBM has over 25 years of history of contribution with open source, including the Linux, Apache, and Eclipse foundations. At IBM, we believe the power of open source is in the community that surrounds an open project. When developers and even companies from different backgrounds, ethnicities, varied training histories, unique perspectives collaborate around making a technology, the result is that the code is richer, more secure, and more innovative.
Hello, and welcome back, and welcome to Irina Shestak. So Irina works at MongoDB, and she's writing in JavaScript and Rust. She gives talks and conferences around the world about her adventures in programming. She's also told me that she's got two cats called Nori and Chatsu, who are both very good. She makes zines outside of her working time. Irina, you can correct me on this, but it's a self-published magazine, I believe. But Irene, yeah, is that correct? Did I get that right?
Yeah, it's like a self-published like little booklet with me. They're like little pages that you can open and read. Yeah, they're bigger ones, but I make pretty small ones.
That's really cool. And today you're going to be walking us through the challenges of bundling your tools together with Node.js, zipping it and distributing it through a standalone package.
Yeah.
Okay.
Exactly.
Over to you.
Sweet. Hello, everyone. How's it going? It's been a few years since my last NodeConf. I think maybe 2 or 3, but I hope you've been well since. I've got a whole bunch of plans in the meantime. Got 2 cats too. I didn't have those last NodeConf for you. But yeah, it's good to be here. And thanks for having me, the organizers. So that is, thanks for having me. All right, so today's talk is about packaging a Node.js binary and how to get it working on several platforms, perhaps 2, perhaps 3, but we're actually working with 5, and I will talk to you about that. And hi, everyone, I'm Irina. I'm a software engineer at MongoDB, and I work on the DevTools team, which takes care of a few different developer tools for MongoDB. Primarily, we work with Compass, which is a GUI for MongoDB. It's an Electron app. We've recently took on 2 new projects. One is the VS Code extension, which lets you work with MongoDB a little bit better in VS Code, like have aggregation pipeline playgrounds and other playgrounds and be able to have different connections. And the tool I'm talking about today is MongoSH. And MongoSH is an interactive JavaScript shell built entirely in Node.js, which is why I am at the Node.js conference. And here today, I wanted to talk to you about the challenges of being able to compile this executable binary, which is our MongoSH project, along with Node.js, and how to get it working in different platforms or how to package it up for different platforms. This talk is meant to be like a little case study. So I wanted to walk you through some things that worked for us and some things that didn't work for us, and kind of tell you about our experiences. These perhaps will work for you as well. Perhaps they won't, and perhaps you've had different experiences. And if those are different, I would like to hear about them. But yeah, sort of like a case study. On the agenda today, a few things. I wanted to talk to you a little bit about MongoSH as a project, kind of how it works, show you a little bit of a demo. I think that definitely will let us know a little bit more about what our build requirements are as a project, some things that we would have to tackle. And then I'll talk to you about how we tackled those build requirements with kind of the packaging epic. A little bit of cat keeping. I've got 2 cats, and it's just past their nap time, so we might have some interruptions where I'll have to give some pats. So yeah, just in case they come in. And maybe I've jinxed it. Who knows? So first, let's talk a little bit about the project itself, MongoSH. I've mentioned before that it's an interactive JavaScript shell, and you might be thinking, well, I already know an interactive JavaScript shell for Mongo, which, you know, MongoDB develops. Don't you work for MongoDB? Yes, that's correct. So MongoSH is a rewrite of the Mongo tool you might be familiar with. And the reason we're taking on this project is because a need to be able to embed this have come forward, and we wanted to be able to have an interactive shell within Compass. So that was kind of how this project came about, and this idea kind of was brought forward. So when we built MongoSH, we wanted to make sure it works across different environments, not just in the terminal like you're used to with Mongo. And so MongoSH was built to be able to work in the browser and Compass, so in Electron applications, as well as the terminal, because of course it's an interactive shell, so it should work in the terminal. And by happy accident, it's also embeddable in JetBrains DataGrip. As we got to know folks working on JetBrains, they kind of came forward and wanted to embed this as well. So it works across different environments. But how is it different from Mongo? And there are a few differences as well. It comes with syntax highlighting and a little bit of contextual help, as well as better error messaging. But most importantly, it's built off a full MongoDB Node API. primarily Node API because our team's experience lies in Node itself. So we could have picked any other driver if we were more familiar with it, but power of the people said Node. And so it's built on top of MongoDB Node API. So if you worked with MongoDB and Node, you have probably used the exact same thing we use, which is the Node driver. And so all the methods that you are used to seeing in the Node driver, we would be using them as well. And you can use that in the MongoSH shell. And so a little bit about how it looks like. You essentially do the exact same thing you would do in Mongo. You can query the same way. You get better error messages. This is just an example of one. And you get syntax highlighted results. But you would query the exact same way, and we made sure that that works out similarly. You can also kind of copy paste scripts and be able to do that as well and get results back. A very short demo, unfortunately, because we want to talk a little bit about packaging. So this is kind of an example of a kind of, I guess this is not a script, but a particular function you can run within MongoSH. I'll get this to run again. So as we're kind of reaching parity with the old Mongo shell, it's still in. Our team uses this in their day-to-day work every day. We're still catching up on some things like change streams and transaction APIs, but lots and lots and lots and lots of API is already within MongoSH. And if you wanted to try it out, you can download it from the download center and see how it works for you. Let us know what you think. We'd love to hear it. Right, so let's talk a little bit about the project itself, like the code itself. I mentioned before that MongoSH is written in Node.js. It's also written in TypeScript. And as a shell, it essentially does two different things. Well, it has to evaluate, and the two things that we evaluate is MongoDB functions and JavaScript functions. If you've used the Mongo shell before, you know that you can write JavaScript. So essentially what we do is we run a JavaScript execution environment. And what that really means for us is that we essentially extend the Node.js REPL, which means we use lots and lots of Node.js functionality within our project. And what that really means is that when it comes to packaging and when it comes to bundling, we need to be able to package our executable along with Node.js together to actually make this all work. And so if you wanted to see, the project is open source, and if you wanted to see how some of the other parts of the application or some of the other parts of the code work, you can take a look in our GitHub project. Today, I'll specifically talk about the terminal or the shell implementation of it and how we actually get the packaging working for that. And so let's focus on the terminal and let's talk about some of the build requirements. I've mentioned that we essentially want to be able to package our project, our executable, along with Node.js. So our primary requirement is to be able to do that, is to be able to create an executable from us as the source code and Node.js. So that's requirement number one. Two, in the future, we want to be able to have native add-ons packaged together in the executable itself. If you've worked with MongoDB, you know that we support Kerberos authentication, and that's something that MongoSH would like to be able to support in the future. So that's kind of like a future consideration that we'd like to be able to do. For our beloved Princess macOS, we want to be able to sign and notarize our package so you don't get the little annoying message of developer is unknown when you download the package. So we want to make sure it's signed and notarized. That's requirement number three. And we want to make sure that the archives or calls that we create, if you're more familiar with that term, could be included as part of MongoDB's personal packaging archive. If you've downloaded MongoDB for a Debian or a Red Hat system, MongoDB has a PPA, where we distribute other tools that we build, and we want to be part of that. So instead of just creating a tarball and a zip archive, we also want to be able to have a Debian .deb and in Red Hat's .rpm archives created. And that would mean that once a user is hooked into MongoDB's PPA list, all they have to do is be able to do sudo apt get install mongosh, which is very nice, even though you have to hook into the list. I think it's a very nice feeling to have. And because I'm giving the talk, I want to tell you all of the things that I just mentioned as build requirements is done and is able to be completed. And if you wanted to kind of take a look into the more gritty how this build is done, you can take a look into our mongosh Lerna build package. And it's linked up in this slide here. Right, so we'll specifically talk about some of the tools we use and some of the tools we build to make sure these build requirements are possible. All right, so let's talk about the packaging itself. One of the kind of, not a hard requirement, but I'm sure we'll all agree and we're all on the same page that it's really, really nice to be able to do packaging as part of the CI ecosystem. That means that we want to be able to have our binary be able to be generated with every CI run, with every PR, and with every commit. And so part of that is for testing reasons, but the other part is that we want to be able to see perhaps on a particular PR that, yes, this Red Hat package works on this Red Hat system and we can download it and play with it. And so that's one of the things that we were able to do. And to be able to do that, there's a few different ways. Like we can write YAML, and in the beginning we did have a bunch of YAML to be able to do this. But what we ended up doing, is kind of writing more or less a Node scripts kind of packaging situation. And so a lot of the decisions that we've made were based on the fact that this is going to be part of a Node script that we're writing and we're running on our hosts. And so what we have, and the way our CI works, is that we have separate hosts that run a certain set of tasks. We have one for each system that we currently support, which is 5 of them: macOS, Red Hat, Debian, Windows, and Ubuntu. And all of them run their own set of tasks, and they're pretty much identical. And so this kind of looks like, from the packaging point of view, outside of like the test and the check and the end-to-end tests, the packaging side of things does essentially 4 steps. The first thing is we bundle our application. The second thing is we create the Node.js executable. And then we sign and notarize it for macOS. And then we create the archive or the tarball or the zip file that we need. And so I'm going to focus on the last 3 portions of this flowchart because we all can agree that JavaScript does not need another bundler. But if you're curious, for bundling, we use Parcel.js, but I'll talk about from everything that goes from there on out. So let's talk about creating a binary first. So the thing that we encountered is that there's no native solution to be able to say, I have a source file and I have Node.js, and I want to be able to create an executable. A native solution like that does not exist. But there are a few different options that we found that are quite good, but unfortunately didn't quite work for us. And I'll show you how these kind of how we ended up in the beginning to use these. So first we worked with PKG for a little bit, and the way it worked was it's very straightforward to use. We use the particular target, Windows, Linux, or Mac, and we just create the executable from it. But the issues that we found with it is that it was a little bit difficult for us to sign to notarize. And I'm saying this, and this does not work for us. PKG does not work for us in our particular use case, but there's nothing wrong with this solution. And I'm not here to diss neither PKG or Nexi. We found that it was difficult to sign and notarize. A tiny little bit of, and you may call me pedantic, we were unable to override process.text title. So then when you do like PSA UX and you wanted to grep for like your process, you weren't able to do it. Perhaps that's a little bit pedantic, but that's fine. And we found that it was a little bit tricky to add native modules with that. So at some point, we basically had a dual compilation or separate compilations for different hosts. And so when we wanted to sign and notarize, we used Nexi. And Nexi, our Nexi compilation looked a little bit like this. That worked fine. So we had dual compilation. It worked for a little bit. But we found that with Nexi, it uses the deprecated third-party main mechanism, which meant that we would have to be only using Node 12x, and we couldn't move past that. It created a little bit of a bigger binary, which is not a big deal if we just wanted really, really to make sure that it's signed and notarized. But in the future, once we wanted to add Kerberos support, it was a little bit trickier to add native modules. And so what we ended up doing is our team wrote our own kind of BoxNode implementation. BoxNode is a package that I'm going to introduce that helped us basically do what we wanted to do. There's an alternative version of the slide in case the cats wouldn't show up, and I promised cats, so I want to make sure I give people what they want. So if you wanted a different introduction of BoxNode, this is BoxNode. What it does essentially is it takes the source.js file and it takes a version of Node.js and puts it all together. So BoxNode is then able to have a single executable that takes those two things and makes it into one. So it contains an executable with both of those, or equivalent of two cats. You decide. And so if you wanted to take a look at the implementation itself, it's under the MongoDB-JS BoxNode GitHub repo. And it's relatively straightforward to follow. And I'm going to walk you through a little bit what happens under the hood. The implementation uses the Node's native embedder API. It's relatively new, but it allows us to do really, really good things with what we exactly wanted. So if you are not familiar with the embedder API, you can find it on the Node.js documentation. It has a bunch of templates that you could use and that we've used and adjusted for BoxNode. And perhaps, so it kind of looks like this when we actually use it. Very simple. You pass in the source file, which is our bundled up with parcel MongoSH, and we say where we want it to go and which node version we wanted to use and what's our namespace, which is MongoSH. We get that all together and we get an executable out of it. And under the hood, perhaps it looks a little bit scary, but essentially what happens is that what it does is it replaces Node's main .cc file, which is the entry file, and replaces it with the MongoSH entry as like using a template. It replaces it with MongoSH. What it also allows us to do is modify the JIP configuration with the native add-on we want to use. So once we want to bring back Kerberos or bring in Kerberos support, we're able to simply add it to the arguments we pass into the compile function, and it modifies the JIP under the hood, and we're able to have that. In the process flow, once it modifies JIP configuration, it then replaces the main.cc file with our own implementation. And when I say it replaces, it literally replaces. And then it compiles Node.js from source along with our implementation, like literally just runs make -j whichever is your CPUS on the current host system. And so then what we end up is having MongoSH compiled together with Node.js, which is exactly what we wanted to do. And again, the API that we actually use in MongoSH is relatively straightforward, kind of similar to what other tools out there provide, but it's really nice to be able to say that our source file is bundled together and it's using a native API where we can have native add-ons in the future. So kind of once we have this executable, we want to see what is the next thing and how can we sign and notarize. And what essentially sign and notarize requires one single thing is for a single entry binary. So it's a binary that, in the terms that we sort of spoke now, it's a binary that has one single main.cc file. And so thankfully that was solved by being able to use Boxnode. And so essentially what we're then doing is using two packages to be able to do signing and notarization. One of them is called Node CodeSign. It's one of the ones we maintain, and essentially the API looks like this. You get the CodeSign and you sign it with the Apple identities, things you have gotten from Apple when you sign up for their kind of for their developer program. And for notarize, we use Electron Notarize, which is maintained by the amazing Electron team. And if you've done anything Electron, they have so many beautiful things that we use in Compass. And this is one of them that we use in MongoSage itself, which allows for a really easy API to be able to notarize a package. Again, just import, pass in the Apple IDs that you got from the developer program from Apple, and you notarize. So all we needed is the kind of like that single entry executable. And so creating archives. So now that we have the executable that's created for the specific platform that we're running the task on, we want to be able to create archives. So kind of the four that we do is tarball, Debian, RPM, and zip. And there are two available packages when we started off, tar, which is widely used in the Node ecosystem, and there's ADM zip that we use to package the zip file. And for Debian and RPM, we wrote two of our own, pkg-rpm and pkg-deb. And the API for them is incredibly similar. You will say, Ira, you just copy-pasted slides, and I will tell you, yes, I copy-pasted slides. And the API we wrote is just incredibly simple. What it does under the hood is it just runs everything dynamically on each of the hosts for Debian and Red Hat, and creates all the necessary files that both of these package managers, package bundlers require. But all you have to do is kind of pass in your executable and where you want it to output. And when we create archives, we basically do it based on which host is currently getting run, because, for example, pkg-deb requires dpkg, and dpkg is usually only available on Ubuntu systems and Debian systems. So obviously we can't create like this archive on a Mac OS, for example, without having that tool installed previously. So all of these are kind of done based on the host we're currently on. All right, so kind of wanted to wrap up the things that we talked about today. So kind of wrapping up sort of slide. Today we talked about packaging MongoSage and the things that we use. Essentially, our requirement was to be able to create an executable that would take our source code, that would take Node.js, and create a single executable that would be able to work in our various environments. We wanted to be able to add native add-ons as part of that executable process, and Boxnode, the tool that we wrote, was able to help us kind of achieve that. Boxnode works in a way where it replaces Node's main file with our own and then compiles it into a single executable. We also wanted to be able to sign and notarize, and we're able to do that with the tools with sign and notarize tools, and that makes it a lot easier by having, that's made a lot easier by having our executable created with Boxnode. And when we create archives, we use various tools as the system kind of provides, and some that we've written, and we're then able to kind of distribute them according to which system we're running in. If you want to try out MongoSage, you can download it from our download center, like I mentioned before. And if you're curious about the build process and kind of how it works under the hood, you can look into our learner build repo in MongoSH repository and see how it is for you. I'm presenting on behalf of a team, and I wanted to make sure my team gets a shout out. As part of this, MongoSage would not be built without them, and so I wanted to make sure they get the recognition they deserve. And when I build slides, some of them are based on other artwork, and I wanted to also put down references that I've either adjusted or sort of recreated. And thank you very much for listening. And thank you very much for listening. I'm Irina on Twitter with an _ and Ls. And if you have questions about MongoSH or Compass or VS Code extension, you can reach me on Twitter or just email us at compass@mongodb.com. Thank you very much.
Thank you so much, Irina. Thank you. We've got one question. Do we have time for just one question? I hope so. Joel's asking how much time does it take to compile and notarize?
How much time does it take to compile and notarize? Was that the question?
That's the question, yes.
It takes about 40 minutes or so. Sometimes longer, sometimes shorter. And we do a little bit of caching on the host itself. So caching meaning for like actually compiling Node.js. And that could slim down to maybe 20 minutes, or it's still a little bit of time. Like it's not cheap time-wise.
Okay. Well, thank you very, very much. I'm sorry the cats didn't make an appearance, but I'm glad they got to be in your slides.
I know. Disappointing.
So up next, we have something a bit different and a bit special from NearForm, especially now in these times. It's important you make sure you look after your mental well-being as well as your physical self. So here is a short meditation session with Rasheen.
Today, I invite you all to do a short meditation with me. We'll start with some breath work and then move on to a body scan. So sit in your chair or come to your yoga mat, wherever you are. Just get nice and relaxed. We want to sit up nice and straight. And just close down the eyes when you're ready. We're going to start by just noticing our breath. We can bring our hand to our chest and our belly. Just notice where the breath goes. We'll start to inhale a little bit deeper and filling right up to the chest. On the exhale, we'll go nice and slow and controlled. Really exhaling every last piece of stagnant air that might be sitting in your lungs. Take 2 more breaths here, nice, slow and controlled. And then we can leave the palms where they are, or we can release them out to our knees. Going to keep the eyes closed softly. Relax the jaw. Relax the face muscles. Relax the shoulders. Relax the hands, the arms. Just bringing our awareness down into our body. You might notice your toes and your right foot, your right ankle, your right leg, your right hip bone, your right hip, your right hand, the whole of your right arm, your chest, your belly, the whole of your left arm, all feeling relaxed. Your left fingers, your left palm, your left leg, your left ankle, the toes on your left foot, all completely relaxed. Again, bringing the attention back to the breath. The mind starts to wander. Inhaling deeply and exhaling, letting go of any tension that you might be holding in your body. Again, inhaling deeply, all the way up from your belly to your chest, and exhaling, letting all that tension go. One more inhale, and exhale. Really getting that last sip of air out of your lungs. Returning to your normal breath. And start to bring some awareness back into the body. Wiggle your fingers, wiggle your toes. Give yourself a little stretch if it feels good. And then slowly, whenever you are ready, blinking those eyes open and returning to the room. I hope you enjoyed that. Namaste.
Hello and welcome back. I hope you're all feeling good, relaxed after that session. And now we're moving on to our next session with Michael Dawson. So Michael Dawson is a member of the Red Hat Node.js team, and he's chair of the Node.js Technical Steering Committee. As well as being an active contributor to the Node.js project, he's also contributed to community efforts including platform support, build infrastructure, and API reference, as well as tools to help the community achieve quality with speed. Michael has also worked on building IBM's Java runtime, building and operating client-facing e-commerce applications, building PKI, and systematic-based crypto solutions. In his spare time, he uses Node.js to automate his home for life and for fun. And we were talking backstage about how I saw Michael about 5 years ago at NodeConf talking about his cabin, which was a small shed that he'd automated, which was absolutely awesome. We will be doing a full Q&A with Michael after the session, so if you have any questions for him, please do use Slido to get those questions in. So over to Michael with real-world Node.js success stories.
Hi, thank you, Katie. And I guess today I'm going to be talking about Node.js success stories, so I'll take it away. before I get started, a little bit about myself. I guess I already had a good introduction in terms of the work that I'm doing in the community, member of the technical steering committee and very active member of a lot of the working groups. But as the node lead for Red Hat and IBM, it lets me work with a lot of the organizations and groups within the two companies that are actually using Node to deploy Node.js applications, and basically cover a lot of the constituencies that we have in the Node.js space. So before I get started, a little bit about what I'm going to take you through. First of all, I want to talk about some real-world success stories using Node.js within IBM and Red Hat. And then I'm going to go to talk about what I actually realized was a success story within an ecosystem while I was putting together the presentation. I'll talk about some customer success stories. And then finally, I'll give you some thoughts on sharing Node.js experience across two large organizations. So just before I get started looking at those success stories, a few things that I wanted to point out were, we're not just working to help our customers and working with the community to build Node.js. We're actually a major Node.js user internally within Red Hat and IBM. We have over 45 different projects who have a registered dependency, and what that means is that they're either bundling Node.js or using Node.js to the extent that they want to know that they have support if something isn't going right. We have a very active Slack group with over 1,600 members who are continually talking and helping each other with JavaScript and Node questions. We have lots of published packages, and really what I came to see is that in IBM and Red Hat, we have coverage for almost all the constituencies that we came up with working on the next 10 years of Node effort. And that's an effort to look at, what made Node successful in the first 10 years and what we should be doing in the next 10 years to continue to be successful. It's an effort within the Node.js project. And, we came up with a list of constituencies in terms of, all the different groups of people who have sort of a stake in the success of Node.js. And it's interesting that, I think we cover all of those. So let's move on to look at two large Node.js deployments, the IBM Cloud UI and the Weather Company. So the first one is the IBM Cloud UI. If you've ever gone to the IBM Cloud, you're using a very large very large Node.js application. It's microservice based, and it lets users create, view, and manage all sorts of platform as a service or infrastructure as a service type resources like Kubernetes clusters, virtual servers, bare metal servers, and Cloud Foundry apps and services. And it's built so that it provides services to any of the teams that want to deliver services through the IBM Cloud, so they don't have to reinvent the wheel in terms of things like registration and onboarding, identity and access management, billing, providing documentation. And so it provides a way that we can reuse all of that logic across the different services. So as I said, it's microservice based. There's about 90 microservices that make it up. This was actually a point in time. I suspect there's more today. It's designed for plugins. And actually, we have over 50 different teams who've designed and written plugins to expose their services. So that tells me that, in addition to those 45 teams that have registered dependencies, we probably have at least another 50 teams within IBM who are using Node.js and writing Node.js code. It's, of course, deployed in Kubernetes, and it's a very large Kubernetes deployment in that it's 10 geoload balance clusters deployed around the world. So, very, very large deployment. It wasn't always that way, though. Back in 2014, it was released as a monolithic single-page app. Everything was loaded within that single page, including the CSS, the HTML. It was served from a single Java app, which also provided like all the APIs that you needed, and it was deployed in Cloud Foundry. Unfortunately, that had some downsides. One of them being bad performance. So the heavyweight JavaScript framework that was being used at the time took quite a while to load. There was a lot of communication back and forth using Ajax, and that created bottlenecks. It also caused problems when we wanted to provide new services, in that it was difficult for those teams to integrate new code. We had to push the whole product, even for small product changes. We were getting poor SEO, and really new hires didn't want anything to do with working on the project because it was using technologies that they didn't find fun to use. So this is moving to a cloud native architecture based on microservices brought a lot of really great benefits. The first one being flexibility. The different teams could deploy at their own schedules. Teams could use stacks of their own choosing. They didn't have to wait for each other, and it really allowed a paced migration so that we could move from what we started with to the fully microservice-based architecture over time. We also found that it improved performance significantly. So we ended up with small microservices which were optimized for speed and page size, which was great. And finally, productivity was greatly increased. And not only could we move faster, but it meant we could move faster with less chances of breaking other parts of the product. So we got lots of the great benefits from moving over to a node-based solution using microservices. Now, some of the lessons learned from that success story is that monitoring is critical. Lots and lots of things can go wrong, and root cause determination can be very difficult. Some of the required metrics that we needed to be able to sort of keep on top of things were, the response time and the response codes for every inbound and outbound request, memory usage, CPU usage, and uptime for all the different microservices, and just the general health of the overall system. So when you move to that microservice-based approach, there's a lot more moving pieces, and so you really need the data to be able to figure out and understand what's going on. So the team ended up moving to a metrics gathering approach that relies heavily on Prometheus and OpenTelemetry, which lets us gather data both on a particular microservice base, but also tracing transactions across the flow of the different microservices. And that really proved to be critical in terms of making sure that we could keep on top of what was going on, drill down when problems were happening, and sort of do an investigation. And so this is one of the reasons why I'm really quite interested in the async local storage work that we're seeing in the community, which we saw Vladimir talk about yesterday, because it's really a key component of making things like OpenTelemetry work well. So it's really good to see that moving forward. The other lesson learned that I wanted to share is that you shouldn't tie the microservices to regions. As I mentioned before, this was a very large deployment, deployed across 10 different regions. And you could take an approach where a particular microservice was tied to a particular region. And really what we found is, that's not what you want to do. You want to make sure that microservices in each of the different regions can talk to microservices in the other regions. And that will, position you much better to handle problems when they come up and be able to do failover and all that kind of stuff properly. The next success story I wanted to talk about is the weather company. You may have already used this yourself. This is an application that provides weather for places all across the world. In addition to the app that you can use to check the local weather, which I do all the time, you can also use its APIs, which provides data so that you can do things like outage prediction. You can get signals about, you can get advanced insights of what's going on, and even breaking weather news, so that you can integrate into that sort of the weather aspect into your application and provide value add. And again, this is another large application, all powered by Node.js. Again, truly global application. It supports billions of locations, lots of zip codes, and very internationalized. So 60 languages across 230 different locales. And again, this is a reason why, like when we saw Node 14 came out as the first LTS release that has full ICU data built in, it's great to see that functions like internationalization are being progressed in the community project so that we can make it easier for these large type deployments to work and be deployed successfully and most easily. In this case, it uses a global infrastructure. Again, in this case, 4 regions, 7 different Kubernetes clusters, over 400 worker nodes, and dozens of services, which may have from 3 to 100 different copies, currently all running in the IBM cloud and serving a very large audience. Again, this wasn't always the way. Back in the old days, it started out as a monolith, and there was a number of problems which are probably going to sound familiar. So performance, it was costing a lot to operate the system that was originally built. It wasn't as stable as we'd like it to be, and developers couldn't move and develop as quickly as they wanted. JavaScript developers, because of course the front end pages were written in JavaScript, so we needed to write in JavaScript, weren't familiar with the backend, which was Drupal and PHP. So we moved to a cloud native architecture using the backends for front ends pattern, decoupling the page front loads, uses server-side rendering, and it uses Node.js microservices to expose all the APIs that are supported for the application. Some of the benefits we saw included velocity. So again, we hear that using JavaScript on the front end and the back end helps you move faster, and this is a case where that actually proves that out. So we ended up with JavaScript on the back and front end, which was easier for developers to contribute because it was easier for developers to contribute across the stack. We achieved better stability. Some of the great tooling in the Node ecosystem, things like ESLint, Jest, and so forth, helped us build a good pipeline and a development process that really, resulted in smaller and more reliable deployments, so that the risk of something going wrong was decreased. We also achieved much better performance. Node used in the right context can scale very, very well, and this again showed that we could, develop an application that scaled really well, much better than the old application, and could be deployed much more cost effectively. If you're interested, you can actually read more about that by going to this link where there's a full case study if you want to find out more details. So the next thing I want to talk about is a Node.js success story of an ecosystem. And I started out with a number of customer success stories, but while I was looking at them, I realized it was really more of a success story about the ecosystem, and this is about IBMI. IBMI is a platform which has been around for quite a long time. It's not necessarily used in startups, but it's used in a lot of companies who are doing day-to-day business, so manufacturing, agriculture, all those kinds of businesses. And what they want is a solution where they don't necessarily need to put together a whole bunch of different pieces. So the IBMI platform gives them an integrated solution with a database and all that. And basically, they want to focus on running their business, not building technology, and it's a great fit for that. So a number of years ago, we all know that open source is basically being very, very successful. And the IBMI team and Jesse Gorzinski in particular realized that open source was going to be a key part of the future. So what they did is they moved on to, they actually worked to make Node.js a first-class participant in that ecosystem. They built NPM modules that were needed to access the native features of the platform. So, an IDB connector and P connector to talk to the built-in database. iToolkit, which helps you support integration with the other native features like calling RPG, which is the native language, and even COBOL. As well as pulling in some ecosystem packages like Loopback to make pulling in new data easier. And by basically building the infrastructure that the ecosystem needed, they made it really easy for IBMI developers to adopt Node. And it was actually really successful because, as we can see, that today in this marketplace survey, over 25% of all IBMI customers actually report using Node.js. And so I look at that as a real success story for the ecosystem. And how did that happen? It happened because the ecosystem looked to Node.js as a piece that would add real value for their customers, put in place the things that it takes to make it a first-class citizen, and then help customers, deploy the applications. And it was very successful in terms of, Node.js being one of the major languages and runtimes which is now used in that ecosystem. Now I'm going to move on to customer success stories, and admittedly, it's only going to be one customer success story because I spent a lot of my time talking about the other aspects, and therefore I only have time to talk about this one. There are quite a few success stories, although we don't have all the customers that we work with because, of course, we need to get the okay from our customers before we can talk about those. So there are a large number of others that I'm aware of, but we can't necessarily share. There's 8 just on the IBMI site itself. So if you want to go read some more details about those particular customer success stories using Node.js, you can go and check it out. The one in particular I was going to take you through is Kras. They create wood products for their customers, and they come along with a very specific requirements. So when they're creating those wood products, they need to make sure that the temperature, the humidity, and all the environmental aspects of when the wood is you know, sort of milled to the requirements meet those requirements. They have a whole bunch of programmable logic controllers, and they wanted to control those to make sure that the you know, the environment was as specified. What they did is they pulled in Node-RED, and Node-RED is a great offering. It's another one of the OpenJS Foundation projects built on top of Node.js, and it provides you a graphical interface, a graphical way that lets you build together different components that work together. And using Node-RED, they could pull together the different components, integrate their programmable logic controllers, and come up with a solution which controlled, you know, in an automated way, those environmental factors when they were, you know, actually building the products for the customers. There is a lab later on in the conference, building cloud-native AI-infused web apps with Node-RED. That is going to be given by Nick O'Leary, who's one of the co-creators of Node-RED. And if you get a chance, it would be great to register and see you at that workshop. I do think that there's a waiting list at this point, but it's always worth getting on the waiting list because we may see if we could offer it again at some point in the future. So now that we've talked about some large some success stories, I wanted to take a few minutes to talk and share some experience in terms of sharing experience across IBM and Red Hat. As you can see, we've got some very large nodes. We have people who are working in the Node community. We have a good number of Node Bethany Griggs, who you saw talk the first day. And a number of other people who you've probably run in if you participate in the community. We also have teams who are going out and working with customers like the IBM Cloud Garage. And we have a large number of customers who are deploying OpenShift where people run Node.js applications as well. So how do we actually share all of that knowledge and make sure that we're basically being as efficient as possible? And this kind of leads back to my thought, which is that we want to make sure we innovate where it matters. So innovation is great, but we don't always need to innovate. So we want to pick where we innovate, and we want to follow standard practice for our organization where it doesn't. But the question is, what is standard practice? If I go to NPM, I did this a few weeks ago, and there's like 1,400,000 packages. And for anything that I want to do, I'm sure I can find a bunch of them. So how do I find the one which is going to be, good, and also that if I'm working with an organization that other people have experience with, and we can share those experiences and we can help each other. So, what we did is we brought together the various teams. So basically, teams who are doing large Node.js deployments. Our people who are working with external customers, the team who is working with on Node.js itself, the team that I'm on, and basically anybody that we could find in the organizations who are using Node or JavaScript. And we got together to say, okay, let's see how we can agree on a standard practice. A few of the things that I think are important to share on this front is that, I've seen a lot of attempts to kind of standardize something. And that's not what we're trying to do in this case. We're not trying to say, here is a set of things that you have to use. So my first advice is don't make it mandatory. There's often very good reasons to use something other than what that common practice is. Even if 3, 4, 5 groups have already used something within your organization, there's good reason why somebody might want to use something else. So don't make it mandatory. The next one is don't claim it's the best. It's really, in my mind, what we know best as an organization. So what have we used? What have we had success in production with? Not necessarily that it's the best, it's just that what we've used already and we have those experience. The next recommendation is to base those recommendations on real world experience, not just research. I can go out and I can look and see which packages have the most downloads, but there's nothing like having used them hands-on in the real world, in those large deployments, spread across 10 geographically distributed Kubernetes clusters to figure out what's going to work and actually gain some real experience in terms of what's some good guidance and how to use it. So base your recommendations on real world experience. Of course, involve broad involvement and build consensus because we need to have buy-in. And in the end, in my mind, it's really just about providing the answer to the question who said, in terms of if somebody has the question, what do you think I should use to have an answer to that? And that's something that we find more and more our customers are asking, as well as our internal teams, because they're focused on innovating, but that doesn't mean innovating throughout the entire stack. They want to innovate in the area that's specific and important to their particular application. So I look at this as building the what do you think I should use if somebody has that question. If somebody already knows what they want to use, then they probably have good reasons, and we're not trying to convince them otherwise. And just before I end, I just, if you're interested in following our efforts, again, you've seen the IBM is Open video, and Red Hat is also very focused on doing things in the open. So we're doing this in an open repo, and you can follow us along at this NodeShift project within the NodeShift organization. And, if you have any comments, you can let us know. So thank you. That's all that I wanted to cover today.
Okay, well, thank you very much, Michael. I've been told that I've only got time to ask you one question, so I'm going to go with this one. If you had to choose one reason for the IBM Node.js ecosystem success, what would it be?
I think it's because that community is actually a lot like the NodeConf community, where when I come back to the conference, that community has a conference, and I've been to it over the last 3 or 4 years. And every time when I come back, it's a lot of the same people. There's a very good relationship between all the people, and Jesse Gorzinski, who's a key part of that community, did a great job of teaching people about Node.js, the value, and bringing the components to the platform that were necessary to make that a real success. So, but I think it comes back to that community being a really well integrated and tight-knit community that really helped make that a success.
Great. Well, thank you ever so much, Michael. That's been really, really enlightening.
Great.
Cool.
Thank you.
So, we couldn't run NodeConf Remote without sponsors, so a big thank you to the sponsors we have: NearForm, Microsoft, Bloomberg, Red Hat, and IBM. And here is a short film from Bloomberg now, and we'll be right back with Karin Angel straight after.
What is Bloomberg?
Well, I can tell you what it's not.
It's never dull.
Bloomberg is
a high-tech,
market-moving, data-driven,
cross-platform
information company.
When we're busy moving the global financial markets,
Bringing transparency to business.
and helping major players change the
we
world.
go through a lot of coffee.
Yeah.
I like grabbing a free snack with colleagues from other teams and other countries.
It helps me get a fresh perspective.
Well, it's about collaboration.
Across teams,
New ideas can come from anywhere.
It's
Bloomberg is the most inspiring place to work that hasn't been discovered yet.
Wow. Bloomberg supports my volunteer work,
Which is refreshing.
Yeah, and there are many opportunities to give back.
The company is designed to solve global problems.
Like climate change.
This is a great place to be if you care about doing good.
We don't think small.
我们拥有超过150个新闻局
in 73 ländern.
世界192箇所にオフィスを持つブルームバーグ
Și în fiecare birou avem toată lumea.
Diversity is essential for business success.
When we're moving this fast,
It's great to know your employer has your back.
the benefits are excellent.
We take that basic nugget of information
From the financial markets
and push it out across all our channels.
Nanoseconds matter.
Faster, but also smarter than anyone else.
And
We help people answer questions they didn't even know they had.
It's all about smart speed.
We're passionate about connecting the world.
With news, analytics,
Data.
seeing every angle.
with the fastest,
real time,
Borderless.
most caffeinated
Organization in the world.
Information is everything.
I see my ideas come to life.
My work really matters. Did I mention never dull?
What is Bloomberg?
Well, I can tell you what it's not.
It's never dull.
Bloomberg is
a high-tech,
market-moving, data-driven,
cross-platform
information company.
When we're busy moving the global financial markets,
Bringing transparency to business
and helping major players change the
we
world.
go through a lot of coffee.
Yeah.
I like grabbing a free snack with colleagues from other teams and other countries.
It helps me get a fresh perspective.
Well, it's about collaboration.
Across teams?
New ideas can come from anywhere. Bloomberg is the most inspiring place to work that hasn't been discovered yet.
Wow. Bloomberg supports my volunteer work,
Which is refreshing.
Yeah, and there are many opportunities to give back.
The company is designed to solve global problems.
Like climate change.
This is a great place to be if you care about doing good.
We don't think small.
我们拥有超过150个新闻局。
In 73 ländern.
世界192カ所にオフィスを持つブルームバーグ。
Și în fiecare birou avem toată lumea.
Diversity is essential for business success.
When we're moving this fast,
It's great to know your employee has your back.
The benefits are excellent.
We take that basic nugget of information
from the financial markets,
And push it out across all our channels.
Nanoseconds matter.
Faster, but also smarter than anyone else.
and we help people answer questions they didn't even know they had.
It's all about smart speed.
We're passionate about connecting the world.
With news, analytics,
Data.
seeing every angle. With a fast,
Real time.
borderless.
Most caffeinated
Organization in the world.
Information is everything.
I see my ideas come to life.
My work really matters. Did I mention never dull?
What is Bloomberg?
Well, I can tell you what it's not.
It's never dull.
Bloomberg is
a high-tech,
market-moving, data-driven,
cross-platform
information company.
When we're busy moving the global financial markets,
Bringing transparency to business
and helping major players change the
we
world.
go through a lot of coffee.
Yeah.
I like grabbing a free snack with colleagues from other teams and other countries.
It helps me get a fresh perspective.
Well, it's about collaboration.
Across teams?
New ideas can come from anywhere.
Bloomberg
is the most inspiring place to work that hasn't been discovered yet.
Wow. Bloomberg supports my volunteer work,
Which is refreshing.
Yeah, and there are many opportunities to give back.
The company is designed to solve global problems.
Like climate change.
This is a great place to be if you care about doing good.
We don't think small.
我们拥有超过150个新闻局。
In 73 ländern.
世界192カ所にオフィスを持つブルームバーグ。
Și în fiecare birou avem toată lumea.
Diversity is essential for business success.
When we're moving this fast,
It's great to know your employee has your back.
The benefits are excellent.
We take that basic nugget of information
from the financial markets,
And push it out across all our channels.
Nanoseconds matter.
Faster, but also smarter than anyone else.
and we help people answer questions they didn't even know they had.
It's all about smart speed.
We're passionate about connecting the world.
With news, analytics,
Data.
seeing every angle. With the fastest,
Real time.
borderless.
Most caffeinated.
Organization in the world.
Information is everything.
I see my ideas come to life.
My work really matters. Did I mention never dull?
Hello and welcome back to NodeConf Remote. Right now we have Karin Angel, and Karin is an experienced software engineer with expertise in building high-scale, highly available performance systems using microservice architectures in Node.js. She's a great believer in testing, specifically the microservice architectures, and she hopes to pass on this passion to others in the community. So please give a warm virtual welcome to Karin with microservice architecture in Node.js automated testing.
Hi everyone. So today we're going to talk about how we will test our microservices architecture in Node.js and basically in every platform, and how we are going to make this whole process cost effective. So first, I'm gonna have a few words about me. So I am a developer for as long as I remember myself, and in the past 5 years, I've been focusing on Node.js. On my spare time, I really love to travel, to paint, and to have a few drinks. So our agenda for today's talk is going to be a short overview of microservices architecture. Why is testing difficult in microservices architecture? We're gonna introduce a little bit the differences between unit tests and API tests in terms of cost efficiency of the tests. We're gonna talk about the importance of integration tests, and at the end, I'm gonna give you a tip. So microservices architecture, right? It's a software development technique, which allows you to build fine-grained, loosely coupled services. They're organized around the business capabilities. They have interfaces which they communicate with. The communication is over technology agnostic protocols, and it has a lot of more to it. A sketch of this kind of a system would look like something like this. You have some kind of a user interface that talks to an API gateway. The API gateway gets the request, understands it, and sends it to the correct microservice. Microservices can talk to each other, and each and every one of them has their own database, which they can query in order to do some job and then to reply to the user. As I said, microservices architecture has a lot of benefits. These are only some of them, right? They enable modularity. They make it easy to integrate with legacy systems. They allow distributed development, so you can develop parallelly different microservices. They allow easily scalability, and they're very efficient, right? But when you're dealing with microservices architecture, you have to take into consideration some aspects, and the aspect that we're talking today about is the testing aspect, which can be very complicated, and we're gonna understand as long as we proceed. So for the rest of the talk, I want to consider a food delivery app. Okay, we are developers in a food delivery app, which is built on top of microservices architecture, and we're hired to the Scooter MS, the Scooter microservice team, and this is the team we're developing on. And on the first day in our job, they're asking us, okay, we want you to add a feature to the Scooter microservice. We need to add live location to each scooter. So the Scooter MS has a database of scooters with scooter table, and we decide that we will save the live location of a scooter to that table. And let's assume that we have already developed this capability, and now we want to build tests in order to push it to production, right? We need to test what we wrote. So the easiest thing to do, the fastest thing to do, is to write unit tests, right? So unit tests, as we know, it's a testing method, which is testing individual sections of the application, which called units. And each unit is tested whether it fits or not the purpose that it was written for. So a unit is commonly a function or a procedure. It allows us to comprehensively test complex application by building blocks of tests. Each test case should be tested independently in order to isolate issues. And we use subs and mocks in order to assist test the module in isolation. So unit test has a lot of benefits. First, we can find the problems early in the development cycle. We are writing the code, running a test, and have a feedback, right? Also, because they're on the function level or on the procedure level, they make it easy to trace the location of the failure. Also, they provide some kind of a living documentation of a system. I guess that every one of you had installed a module, and the first thing you do to learn that module or how it works, you go to the tests, right, in order to see how you are initiating or how you're starting to run the code. And it also ensures modules to work after a refactor or an upgrade in a later date. So let's say we are adding unit tests to our food delivery app, and we're testing the ability to update the live location of a scooter. So the first thing I'm doing is creating a scooter. The second thing is I am updating the longitude and latitude for that scooter. The third thing that I'm doing is querying the database, checking the database, asking the database what is the information of the scooter, and then I am checking whether the update occurred. And as I repeatedly said, I'm querying the database. And as this one unit test that I have a lot of more unit tests, all querying the database. But 1 month later, we've become bigger. We have a lot of scooters, a lot of drivers. We have decided that we want to change the implementation of the live location of scooters. So now we want to shift from the database to Redis. But what about our unit tests? They were querying the database. Now we'll have to change all of them to query Redis. And changing tests, it's a good scenario. The bad scenario would be that we will have to rewrite the entire test suite. So what if we wrote API tests in the first place? So API tests are much like unit tests, but they're basically testing your application on the API level. It's business logic oriented. Okay, so it tests whether business logic through the API actually had happened. And much like unit tests, again, each test case should be tested independently in order to isolate issues. And we, again, using stubs and mocks in order to test a module in isolation. API tests has a lot of benefits as unit tests, but the key differentiator here is that it is tolerant to underlying implementation changes. So if we have a little comparison between the two, so the API tests are at the API level, they're higher in the hierarchy. They're business logic oriented. There are fewer tests to be written because we don't need to test edge cases that are not interesting. If the business logic is not going to go there, why to test it in the first place? And again, it's tolerant to implementation changes. It doesn't care what is the underlying implementation, whether we were using some kind of a database like Mongo or whatever, or moved to Redis. It doesn't care. We're testing on the API level. On the other hand, unit tests allow us to test the functions themselves, and they allow an easier location of the failure. We can locate the failure more easily. So which one should we use? I say use both. You should cover your APIs with API tests really comprehensively. And only the critical or crucial functions that you have that are on the critical path of your application, you should test for edge cases. Not every function needs to be tested with all of its edge cases. So if we go back to our food delivery app, I would have written the test in the first place like this. I would have created a scooter, then I would have updated it, and then I would have queried the API. So all of these requests are API requests that I'm doing. And I would have written all my tests through the API, and then these kind of changes of using different database or using a different storage wouldn't affect the tests. And you can think of more examples for this. Okay, so 1 month later, again, we want to change the implementation of Scooter Live Locations again. We've decided that the Scooter Live location is taking the entire logic is taking a lot of space in the Scooter MS, so we're moving it to a different service altogether. And the Scooter Live Location MS exposes an API to initialize the live location of a scooter with a specific state, and we are on the Scooter MS team and we're consuming that API. So we need to specify the latitude and longitude in the body of the request, and we need to specify the state in the query string of the request. And again, we in the Scooter MS team are consuming this API. So let's say this is a piece of code that in which we are consuming the API. See, I have here the Scooter live location network, and I'm doing an update of a scooter with the state and latitude and longitude. So this is a piece of code in which I'm consuming the Scooter live location service. And now I want to test it, right? So I need to write a test. And see, I am passing the state, the latitude, and longitude in the body of the request. So, okay, let's proceed with this code, and I'm writing a test. So in order to test, I am writing a mock for the live location service. And I'm saying, so with this test, I'm going to send this and this state, latitude and longitude. And again, I'm sending it in the body of the mock because my code is actually going to do that. But if you remember, we said that the API of the Scooter live location is expecting the state in the query string. So what we're going to have here is the tests are going to pass because I had a bug in my code in Scooter MS. And I continued that bug into the test, and I wrote tests that correspond with my buggy code. The tests are going to pass. But when we'll go to production, it's not going to work because the integration between the Scooter MS and the Scooter live location MS is wrong. One was sending some data through the body of a request, and the other one was expecting it to be on a query string. So it's not going to work, although all the tests have passed. So for that, we need integration tests. So basically, integration test is combining a few modules or a few services and testing them all together. Basically testing if they perform the needed business flow. Again, all the microservices that are tested within the test need to be brought up for the testing. The benefits are, like the key differentiator here is that integration tests expose faults in the interaction between the units. Why not do only integration tests? Again, they are very late in the developing process. They consume more time to write, to set up, and to run. They make it harder to locate the root cause of the fault. You don't know where in the chain of event there was the problem. Because we need to set up the entire environment, it's a higher cost. And this one I already said. So a testing process in terms of cost efficiency should look something like this. While you're developing, you want to have a fast feedback from your tests, whether your code is working or not in the capsule of this microservice. So you should write unit tests again for your critical code, for your crucial functions that maybe they're making a complex calculation or something like that, but there are functions that you don't really need to have unit tests for. They will be tested through your comprehensive API tests as long as the flow is working correctly. They will be tested. And right before you're deploying your new code, again, run the unit tests, the comprehensive API tests, and here you're gonna run the integration test that you've written. And this is how a good testing process of microservices architecture should look like. So up till now, we talked about pre-production tests. What's about after we're releasing? So post-production testing, and this is the bit I wanted to talk about. So post-production testing is basically an approach of testing and monitoring your production environment. So first of all, you're going to ask me, why should we test our production environment? Why is it necessary? We invested so much in testing up till now. So first of all, you all should know that we cannot test everything. If you've shipped a product, you missed a bug. Each and every one of you, if you have clients, they've called you, they told you something is not working correctly. So if you did post-production testing, you might have seen that bug before the client would have. And also, testing and staging environments are never identical to production. It's like comparing a zoo to nature. In production, you have real user requests, you have latency of the databases, and when you're testing, you're using stubs, while in production, that stub is not, there is no stub, okay? So the stub is being written by you. It can be buggy, it can be different than the real production component that you're stubbing. And it could work differently. So I think that I made my point why you should do post-production testing, and you should use it. Don't only do that, right? You should use it as a complementary solution to the pre-production testing. So there are some practices of post-production. So we have canary testing. Basically, it means if you have several machines with the same service, change only one replica and see and navigate the network to that some of your network to that replica, and then see how it behaves and have some kind of statistics over it. Control test flight is basically the same thing with users, only expose a small group of users to changes or to new changes in your code and see how it behaves. These two approaches are good if you have a lot of network requests or a lot of users. Because you're only sending a small portion of them, and you need to have a significant amount in order to have a good statistics. What you should do if you don't have a lot of users or a lot of network, use synthetic user testing. Basically, it means make fake users and write some scripts for them to do set in your system and see how it behaves, and then you'll have statistics. And the last practice I have here is fault injection. Basically, it means create problems within your production environment, and see how gracefully this problem that you've created is handled. Basically, you can do something. You can pull down an entire service, or take out a database, or have a lot of network, so have load on your system, and see how your system is handling everything. This practice is being used by Netflix with its Kiosk Monkey routine. So to sum up, we should use the best of all worlds in order to test our system, but we should do it in a smart way. We don't want to add unit tests for everything. We only want to test our critical functions with them. We will comprehensively test our APIs, because our business logic is the important part of the system. And then we will add integration tests of business flows to our microservices, in order to see that the business flows are working correctly. And at the end, after we shipped to production, we will test in production, of course. That was me. If you have any questions, I'm here for you.
Okay, thank you very much. That was really, really interesting, Karin. I was particularly interested in the testing in production side of it. I had an amazing bug recently, which was a cache bleed issue that only showed up in production. And it does sometimes that's the only place you're going to catch those sorts of things. So hearing all those sorts of ideas about how you can try and mitigate against those sorts of problems was really interesting. Thank you. So I have some questions for you. So first off, we have one from Antonio. Let me bring it over here so I can read it. Antonio says, one of the hardest things to test in a microservice architecture, from his experience, or from their experience rather, is testing the asynchronous processes, so the event-driven architecture. Have you faced this situation?
So I would say, well, it depends. The asynchronous processes, I guess it's between the microservices themselves, as I understand. So sometimes we want to add stubs for the tests. The other thing that we can do is to have the tests running, and then to wait for the asynchronous reaction to happen, and then to kind of call the response. That's from my experience, that's the things that we did up till now.
Okay, thank you. So say I had one microservice and I was splitting it into two microservices. What would happen with the tests in that situation?
Okay, so as I said before, if you write good tests, or you write in a comprehensive way your APIs, then if you have one microservice and then you split it into two, then some of the logic will go to one microservice and the other logic would go to a different microservice. So you can like 80% or 90% of the tests of the API tests, you'll just have to copy and paste to that different microservice that now you have splitted. And maybe you will have to add a little bit more tests, and also tests are going with the code that had went. And again, you'll have to add integration tests for these two microservices that are now interacting with each other.
So you're testing the contract between the two new microservices as well as the internals of it.
Exactly. So if you've written from the beginning the API test correctly, then you'll split it into these two microservices, and then you'll have to add the integration, the contract, exactly, the API between the two, that they're working correctly with each other.
Okay, thank you. So we touched on the sort of problems that I personally encountered in production, but what sort of issues have you encountered in post-production tests?
What kind of problems did I encounter in post-production?
Yes.
So one time I actually encountered a problem that if we had a canary release, then we would understand that we would go back, fix our problems. One of the things at the beginning, when we are a small startup, you don't have a lot of money or time to invest on integration. You're testing more your each and every service, but you don't have a lot of time to invest on integration because at the beginning you don't really have clients. The only ones that are facing the problems are actually the developers themselves. So you're not investing on integration. And then we had a lot of problems there. One developer was developing one microservice. The APIs were building as we were going. We were just talking like you and I, hey, dude, what these API is looking like? And he was telling to me, we are human beings, we were writing code. And then at production, it wouldn't work correctly, but because the loop was really, really small, we could fix it really fast. When we went to the stage that we have users, then we understood that we must add integration tests and post-production tests. Because one time, for instance, I was testing against a false database, okay? A database that I have, like the tests are not really also in the integration phase and on unit tests and API tests. It's a false database, right? It's not the database of production. One of the components that we have written wasn't working so well on production, and there was some kind of performance issue. Because there were a lot of drivers, for instance. So we had to add some kind of pagination or some sort of that thing to solve it. And if we had a test flight or some kind of a canary release, we could have understood that issue on our own before the clients.
Okay. Well, thank you very much, Karin. That was great. And thank you very much for your talk. So next up, we have the virtual booth crawl. So I just need to explain a little bit how this works. So if you are looking at NodeConfRemote.com at the live feed, and I was just checking the URL then, you need to scroll down. Scroll all the way to the bottom of the page, and at the bottom of the page you will see a number of links. Now on those links you've got the opportunity to join different calls where you'll be able to interact with people from IBM, with people from Bloomberg, with people from NearForm, and people from Red Hat. And today you've got an opportunity to go to two different things from NearForm. So you could go to join James for a game of Among Us, or join Connor to talk about the history of the NodeConf badges and what's been done over the years for NodeConf badges. After that, we'll be coming back over here to the last three speakers of the afternoon. So we've got Luca Maraschi, James Snell, and Luke Holmquist. So go enjoy the booths, and we'll see you back here soon. Hello and welcome back. And we're here with Luca Maraschi. So Luca has a great enthusiasm for a tech industry, something that started when he was just 6 years old when he started coding. It's something that I've been privileged to witness when I've watched his various talks in NodeConf over the years, right back to 2015, which was my first NodeConf, when he was speaking about the magic dump, which was all about the perils of fixing live bugs at 3 a.m. We've had a lot of late night chats about cloud architectures and some very animated conversations about software architecture. In fact, just now we were talking backstage about open source and the importance of it in building the tech industry going forward. So I'm going to pass you over to Luca, who's going to talk from mesh to mesh using Fastify.
Thanks, Katie. It's always a pleasure to be introduced by you and to be here at this fantastic conference. I've been here for a few years, and I can say it's still my favorite. So today we are gonna go again through a journey, right? I'm very famous for these stories, for these tales, for this nice walk through some personal experience. And this one is the metamorphosis of digital platform. And we're gonna do it from the mess to the mesh using Fastify, my favorite library. And I want actually to start recognizing the great success and the great work that the whole Fastify team is putting every single day in making this library a top-notch library. And I want to say it in Italian, and I want to say grazie to everyone. Let me introduce myself. I am Luca. Perfect pronunciation of my last name, Katie. My name is Luca Maraschi. I'm the VP of Engineering at CTO.ai here in today rainy Vancouver, but usually sunny. And before joining CTO.ai, I was chief architect at Talos Digital. And so I've been through a lot of experiences in digital transformation and API transformation. And but you know, you all probably came to one of my talks, and you know that I can't avoid talking about food because I'm Italian, because I love food. And today I want to talk about one of my favorite simple but yet super difficult to get right Italian dishes, that is the cacio e pepe. And this one is the risotto made by Massimo Bottura. And it's very interesting that I mentioned this theme because, and very important to me, because Massimo invented this plate. He revisited the famous bucatini cacio e pepe, typically from the Roman tradition, to basically rescue a lot of wheels that they got damaged from Parmigiano Reggiano. So, and this dish actually represents for me one of the key values that I hold on and I try to embrace every single day. That is, simplicity is the ultimate sophistication. I told you it's a very simple dish to make, right? But yet so complicated to get right. And so let me start this journey like my usual start. It all started with the monolith. And we all have been there, right? And so this monolith that I want to represent like the Russian dolls, the matryoshka. And why? Because there was a lot of encapsulation, right? Things that were like all nested inside of each other. They became sometimes hidden. You didn't know what was inside until you discovered the tiny small one, right? But it takes some time. So it's complicated. And then the next step in this transformation were microservices. You all heard my talks, what I think about it. But yet, you know, I want to kind of tell a few of the challenges of microservices, right? So service discovery, a long time ago, Matteo, Collin, and I made a beautiful talk in Amsterdam about Consul and service discovery, which actually leads us to service registration. How do we keep a perfect topology of our services, and how do we version them, right? Because clearly now you have a lot of microservices that they have dependencies between each other. And then the infamous auth-in, auth-z, authentication and authorization, right? That in microservices, what commonly we saw is that, you know, you use Express or any other Node library, or if you use Java Spring Boot, it's basically a middleware or a library that you use. So every single service has to implement it. And then as more services are added to this system, observability becomes extremely important. And so we all heard about Zipkin, or it's underneath protocol that is Dapper or Jaeger or open tracing. And then the last but not least, one of my favorite challenges, circuit breaking and resiliency, right? So how do we make this system fault tolerant? And so, because at the end of the day, if we take a 10,000 feet overview, we are basically building a distributed system, and such as the entropy is super high. So it becomes a very kind of complicated system to manage, to handle. And one of the main challenges there is determinism and coordination, right? Because, with more microsystems we add to the overall system, the more complicated the coordination becomes. And so the main question has always been, and I witness it and I have to answer it. How can I be sure that every API is using our best practices? Because that's the challenge. You start to distribute your teams, especially in this crazy 2020, with the distributed teams and remote teams becoming at the core of businesses. How do I do that? And so this is what you get, right? So I didn't want to use the spaghetti because this one is the spaghetti code. So I didn't want to create a conflict of interest. But this is basically what's usually happening, right, in microservices. And I saw it with my own eyes, probably not so colorful, because most of the time it becomes a huge traffic jam, right? Traffic coordination becomes impossible to manage, and it becomes convoluted, congested. The main issue that I see every single time is that you have service A try to call the database of service B. And so what you usually implement is the so-called central API gateway, where basically you have the web traffic going through the gateway, which dispatches call and coordinate as a sort of enterprise service bus to all the services. And so this is the so-called north to south traffic. And, I'm going to give you some ingredients for this recipe, right? The first one is Kong. It's my favorite API gateway. I think there is nothing is as good as Kong. Check it out. Kong is at the core of this picture. And but we are looking at north-south traffic. And so what about east-west? So the service to service, the traffic thing that I was telling you earlier on. Well, that one is the service mesh. And that's why you're over here. We are going from the mesh to the mesh, right? So how does a service mesh usually look like, right? So you have a data plane, proxy, most of the time Envoy. Many years ago, going back to 2013, when I designed the first service mesh, I used Nginx. And as you heard, recently Nginx just announced their Nginx service mesh. But how it works is basically every single service communicates only with this local proxy, and the proxy acts as a trampoline. It basically reroutes traffic to another service, right? So the service, they don't communicate with each other, they communicate to an intermediary proxy. Usually is HTTP or TCP. Sometimes there is mutual TLS. But the core point is that everything is coordinated centrally by a control plane, right? And policies and telemetry and many other functionalities, they are injected into these proxies. And I cannot say anything better than Kuma is the best service mesh in the market. That's it. I tried them all, but nothing is as good as Kuma. And why? Because Kuma, first of all, allows you to abstract the concept of the underlying infrastructure, right? So Kuma is like a real proxy that helps to operate on different kind of infrastructures, both on-prem and on cloud. But most and foremost, they offer security and MTLS out of the box, traffic control, observability, service discovery, and something else. So let's take a little bit of a step back into the picture that we are starting to paint, right? So we have an outer ring that safeguards north to south traffic, Kong. We have an inner ring that safeguards this mesh. Kuma can support multi-mesh, but is not the point of this talk to explain how Kuma works. But check it out. And so we have the service-to-service communication done. We have the outer network. We have some responsibility there. Then we have our responsibilities that they go in. And believe me, it's not a matroshka, this one. And if you look at how the picture starts to paint, so what is really a service mesh? The service mesh is just an overlay network, right? Let's call it for what it is. A long time ago, Uber created something similar called Hyperbahn, that was an overlay network for having the ring pop instances to communicate between each other. But this service mesh concept actually acts on two layers, layer 4 and layer 7. So the pure network or the cloud and the cloud infrastructure and the application layer. But there is still a gap, right? How do we put our application? Where do we put our application? I believe if there was an OSI layer 8 and 9, that would be the business logic and the developer experience, right? So let's try to dig a little bit deeper there, like Fastify, no other word, the best web framework in the Node.js ecosystem. And now I'm going to tell you why and how it fits the mesh concept, right? So if you look at Fastify architecture, it's simple, elegant, sophisticated. We have a bootloader, well, not really a bootloader, a loader, a VO. There are some primitives that allow extensibility. There are plugins, decorators, and hooks. And then there is the router, the best in class. Find my way. This is Fastify in a nutshell, right? And it's very important that we focus on this central part, plugins, decorators, and hook. Because if we take a little bit of a step back in how a Fastify app usually works, is that you load plugins. A view is able to consistently and deterministically load the plugins with their own chain of dependencies and push them into the Fastify app. So then you have your servers.listen and your API is up and running. So if we look at how plugins, they are actually kind of structured and what kind of encapsulation they guarantee and they offer, it's actually extremely interesting. A plugin which derives from a base class that is a Fastify plugin can have nested dependencies, can be encapsulated. And this is deterministic. So the way, and isolated. So the way a plugin can encapsulate dependencies is guaranteed to be consistent. And this is extremely important. If you look, we have a plugin with inside another plugin with another 3 dependencies, and these are loaded consistently. So if we look at a monolith, how you'd build it, right? You just put all plugins inside of a single application. But the beauty of Fastify is that you can transform that monolith. So you can start with a low infrastructure footprint and complexity and move into microservices in no time. Why? Because you take your plugin, you move it outside, put it inside of an app, and this one will be a micro app, which will run your plugin functionality, right? And so if you look at a little bit further, right, in this picture, you see that actually we can enable extremely interesting functionalities thanks to the plugin architecture. So let's think about secret injection, right? The elephant in the room for anybody. How do we solve it, right? So if you look at Docker, it uses basically environment variable injection. And if you are using HashiCorp Vault, like you should, or for example, AWS KMS or GCP KMS, what happens is that you store their secrets and variables, and those are injected. And if you use .m, you can then push them through your Fastify application. But what gets very interesting is that these application can propagate these variables as options inside of the plugins. So, and this is beautiful, right? Because you are enabling this kind of very kind of interesting workflow, right? Where your Fastify apps become some sort of dispatcher. And so if we look at, for example, how usually you start a Fastify app, it gets even more interesting. I think Fastify CLI, you should use it. That's it. Go npm install Fastify CLI and, Fastify start, and you can load your plugin. because this is the whole concept, right? What I told you before is that Fastify can become an application container. And now you can build this micro application that can be distributed, right? Extremely interesting, extremely elegant. If you look at usually how an application is designed, clearly you have routing, validation, business logic, you know, the north, south, and then you go in and you have all these non-functional requirements. Usually are middlewares in traditional applications, or sometimes they are plugins, and you can use hooks to kind of intercept the event chain between the Fastify loader and the request handler. But what gets very interesting, if we take a step back and go back to our friend Envoy and Kuma, is that most of these things that are coming out of the box using Kong and Kuma. You have authentication with Kong. You have logging and tracing that is propagated through the mesh, and then you can do outside. And so your Fastify application, your application starts to become smaller. And now you have functionalities that they need to be consistent, that can be centrally controlled by the control plane. And so Service Mesh allows you to basically have Open Policy Agent for your policies, or OAuth 2.0 or OIDC and Jagger, right? Out of the box. Last thing to do in your application. But let's go take a step back into our primitives, right? What are the primitives of a service? Roots, validation, and business logic. And how do I make a deterministic service runner? Because that was the whole point, determinism, right? How can I guarantee consistency? How can I guarantee that my basic application is the same across all my different deployed APIs? And this is kind of draw a line, a demarcation line, as I love to call it, between developers and operators, right? Because developers want to develop fast and operators want to operate consistently. So let's look into Fastify autoload, right? And let's add a pinch of salt, right? And in this pinch of salt, the interesting piece is that if you basically start to load the dependencies, you can start to rethink about the application as some sort of operating system, right? So Fastify can then load, and we talked about hooks earlier on, can load dependencies that are coming from a centrally managed config. So we have this config with all our plugins, and then we can use autoload to load dependencies that are declared outside or inside our Fastify application. And this is actually started to get very interesting, because it means that I can have plugins and functionalities that are coming from different sources, right? Which means that I can start to encapsulate and isolate some kind of common pattern and practices, right? And distribute them as a way to consistently have functionalities across, for example, our scale organization, an enterprise, or even a startup, right? And this resembles of an operating system bootloader, and this is actually allowing us to consistently create a service topology, or like I love to call it, a generation. Imagine this kind of living system, right, that changes and continuously evolves. And so if you look now, our application, we have an abstraction on the infrastructure, Docker. The application becomes a runner, and then we have plugins that represent business functionalities, so basically APIs. And then we have all the non-functional requirements that are controlled by the service mesh. And this is actually some sort of magic, right, that can happen in combination with how configuration can be handled by Fastify. And so this is probably was one of the most interesting pieces, right? I can actually have configuration per plugin. As we said, they are encapsulated. I can have a global configuration, and I can have a globally mutable configuration. So I can have a configuration that comes from some sort of outer source, and one that is embedded within my runner. So this one is allowing us to kind of lower the footprint on developers to take care of non-functional requirements. And so this is the mission that somehow we are, pursuing at CTO.ai. We believe, and I believe, having built this platform, that the future is for, as I call it, evolve a modern Heroku that lives for everyone on a mesh. And last year, I was chatting with Katie right about this federated cloud, a cloud that takes down all boundaries and becomes a universal cloud. And I believe that as more we are going to simplify our application runners, and thanks to Fastify, this is possible in a super elegant way. We will be able to create these really boxes where developers will be able to deliver extremely fast value to market, lowering the cost of experimentation, POCs, right, and delivering more value to our customer and to the market. So I am welcoming you and probably also encouraging you to join our CTO.ai community if you want to hear more about this mesh, this idea. We're going to open source it, clearly, most of the pieces, but join our community to be kept always up to date. And I want to leave you with ciao. Thanks again to everyone.
Thank you. Thank you so much, Luca. That was amazing. Got time for maybe one, maybe two questions. So I'm going to kick off straight away with, how does the plugin model implemented by Fastify differ to one provided by other frameworks such as Happy.js?
Oh, yeah. So it's all about the determinism and the algorithm that is behind Avio. I think the magic there is mostly Avio, and that's why it differs. So that is the way the determinism and the encapsulation are guaranteed, and that's why all this kind of let's build a basic container that can be shared across and reference those plugins is possible. So I call it actually this one a natural evolution of any service mesh.
Question for you. To migrate an application written with Express to Fastify, do you recommend to rewrite the code base or to use Express plugin? Could that be a good compromise?
Yeah, so Fastify 3 actually introduced this huge breakthrough, the possibility of using to embed Express applications within Fastify. I would actually say, and that's my favorite term, is the strangler pattern. You can actually take your existing Express application within Fastify, and you can already start to implement the model that I just showed, because your application will run inside of that context. And then you can start strangling application, separate the concern, right? Because most of the time are all middlewares. And you can take these middlewares, put them inside of, some functionalities that are coming out of the box from a service mesh or an API gateway, and then strangle more and more and more so that you can basically reduce the footprint of your application. So I would actually start with the strangler and then slowly rebuild based on also business value and business impact.
Yeah. I've got to say, I think my favorite pattern is the strangler pattern as well. Listen, there is another couple of questions, and what I'm going to say is we are out of time. So what I'll do is I'll ask Luca to maybe get in touch with you on Twitter or something, so that if you've got any questions that you want to ask him, please do just go ahead and ask, and he will answer them. So thank you very much again, Luca. Up next, we've got some fun facts from Red Hat. And after that, we will be joining James Snell to talk about Piscina. Hello and welcome back, and welcome to James Snell. So, James is the head of research at NearForm, and he is a core contributor to Node.js. He was the runner of the Code and Learn session that got me my first, and let's be honest, only contribution to the Node core, which I'm very, very proud of, and I've still got the badge. He's on the Node Technical Steering Committee, and he used to work for IBM. And the most important fact of all is, according to one of the developers I used to work with at the BBC, he has got one of the most recognisable beards in test. Please virtually give it up for James Snell and jumping into the deep end with Piscina.
Hey, thank you, Katie. So it's good to know you still have the badge. Do you have it somewhere prominent?
It's in a special bag because the back broke off of it, but I look after it still.
Oh, okay. I've got an extra one. If you lose that one, I'll slide you an extra one.
I'll let you know.
All righty. Yeah, thank you very much. Okay. So, hello, everyone. I am James Snell. I am head of research at NearForm. As Katie said, I am a core contributor to Node, which basically means that I get to work on Node all day long, adding things, fixing things, typically fixing the things that I added. But it's a lot of fun. One of the things that we added recently was worker threads. It was added, a number of years ago. But earlier this year, we discovered that there's still a lot of misconceptions, and a lot of folks don't quite understand how to use them. We had one issue that was open, for instance, where this person was like, well, I have this app where I'm running 2,000 worker threads at the same time, and there seems to be a performance issue. It was a memory leak. And there was a legitimate bug in the code, but the thing that stuck out at me, with this issue was, why are you running 2,000 workers? Unless you have a machine that's got several thousand cores available, it's probably not something that you should be doing. Particularly if all of those are CPU-bound tasks, you're going to run into all kinds of performance issues. So that issue really led to the creation of Piscina. Piscina is a worker pool, a worker thread pool project. And to understand really about kind of how it works, let's kind of step back and look at the anatomy of worker threads in Node to kind of see how they work, so we can understand what's happening under the covers. Every worker thread in Node is essentially a separate Node instance. It has its own copy of the Node environment, which is where we maintain all of our internal state, its own V8 isolate, its own V8 context, and its own instance of the Libuv event loop running in its thread. All of those, whether it's the main thread, all of the worker threads, all share a common Libuv thread pool. So all of the things like reading from a file system or accepting a network request or whatever, right? That's happening in this shared environment, whereas each of the workers themselves have their own distinct Node environments. So there's a lot going on in there. In each one. So every time, if you're creating 2,000 of these things, you're essentially creating 2,000 separate copies of Node running at the same time with their own event loops, all contending for the same CPU space. They have the same memory, everything else. So you have to use them diligently to know what to be able to realize any performance benefit out of them. So a couple of key questions come up. What are the best use cases for worker threads? Are worker threads optimized for I/O or compute-intensive tasks? How many worker threads can or should you create? And how do you know if you're using them correctly? Well, worker threads are best used to move event loop blocking tasks, so compute-intensive tasks off the main event loop. But only if those cannot be optimized in other ways. I'll talk about that here in just a bit. Again, we really want to focus on compute. Anything that is already optimized for asynchronous I/O in Node is going to see very little to no performance benefit moving them to a worker thread. There's no single answer to the number of worker threads that you can create. Piscina, for instance, will typically go 1.5 times the number of cores you have available. It really depends on what those threads are doing, how active they're going to be. The thing you want to avoid is having those contend with one another for CPU time too much. A little bit of contention is okay. but you really have to tune it to what it is you're doing. So no single answer. It's just whatever your application is doing and what makes the most sense. So you have to do a lot of profiling. And how do you know if you're using worker threads correctly? This is the much more difficult question. And this is why a project like Piscina exists. So Piscina, we wrote it earlier. I think that's like last year, earlier this year. I have to say, Anna Henningsen did majority of the work on this while she was with us at NearForm. It's written in TypeScript. It supports both CommonJS and ES6 module usage. You can install it with npm or yarn. Just npm install Piscina or add from yarn. It's really straightforward to use. You create the instance. You tell it which worker you want it to run, and then you give it a task, or many tasks for it to go off and do. Now, what Piscina is doing under the covers, it's maintaining a pool of available workers that are going to run those tasks as you submit them. When they complete, it's going to resolve the promise that run task gives you. The QR code here will just take you to the project on GitHub, so you can dig in more. But we're going to go through some code here in just a bit to explore some of the features of Piscina. Before we get into more of the code, fast communication between threads. We are using the optimized communication channels. You heard Anna talking about message ports and some of the worker communication channels yesterday. We are covering fixed task and variable task scenarios. We'll talk about that more. Flexible pool sizes. You can tune the number of workers that are available. Proper async tracking integration. Basically, Node has built-in mechanisms for asynchronous resource tracking. If you're familiar with the async hooks API, we're integrating with that correctly. We're tracking statistics for run and wait times. You can see how efficiently you're working, and we're going to be incorporating the event loop utilization stuff that Trevor talked about yesterday into this as well. You can cancel tasks using a board controller and a board signal. Supports enforcing memory resource limits. So if a particular set of workers go over a certain memory usage or CPU usage, whatever, you can limit those. And like I said, it supports CommonJS, ESM, TypeScript, and native add-ons. So it's very flexible. The whole reason Piscina exists is to take the guesswork out of using worker threads correctly. Now, one important point is Piscina and the worker pool model is not the only way of using worker threads correctly. It's just designed to cover majority of typical use cases. So let's switch over and do some examples. I'm going to switch over my screen here and share some VS Code. Take just a second. All right. So the code is out on GitHub. If you go to github.com/Piscina.js, I'll put the links in the chat afterwards, and I'll have them on Twitter as well. But the project itself, like I said, really straightforward. Once you've installed it, you're going to just require Piscina and create and get the Piscina constructor object. You generally only want to have one instance of this per process. The reason is, it's maintaining a pool of these workers. If you have multiple pools active at the same time, then you can run into some issues with those contending with each other since they're not aware of each other. Fortunately, as I'll show you later on, it's possible to have a single instance of the pool running multiple workers per task. So, so in this example, we're just creating one worker for the entire pool. It's not the only way to do it. So generally, you only want to have one of these running. Once you've created it, you give it a task. And a task is really just an object that describes what work you want it to do. The worker.js that you give it is the thing that actually has the code for that. Consider the object that you pass the run task. These are just the input arguments for that task. That's going to give you a promise back that you can await, wait for the results. Whenever that worker thread is done executing that task, it's going to give you the result and get back to you. The workers themselves, very straightforward. It's just a module that exports a function. Now that can be a regular synchronous function, or it can be an async function that returns a promise. Piscina will do the right thing either way, and it'll just work. You can also use ESM, like I said. So if you're using that ESM syntax, it'll just work. You pass it to the MJS file. and Piscina will just do the right thing when it's loading that. Tasks can be canceled. So, just talking about this, you can use the abort controller that's out on NPM. So if you just npm I abort controller, you'll get a fantastic implementation of that API. Or you can use the new abort controller that's built into Node. If you're on Node 14 or 15, it'll be there. Once you create the task, you go in, you can pass in the signal for that. And then later on, if you need to, you abort controller abort, it sends a signal and the promise will be rejected. Again, this is designed to be as straightforward and simple as possible. Alternatively, any event emitter that emits an abort event may be used as the abort controller. So if you don't want to use the standard API, you can use this, do this as well. Sometimes workers need to have some initialization. Maybe you need to connect to a database or do some other initialization step. That is as simple as instead of exporting the function directly in your worker, you would export a promise, and whenever that resolves, the worker will become available for Piscina to use. Just keep in mind that Piscina will create a multiple instances of the worker. So if you are doing some initialization steps, that's going to run for each worker that is created. You can have some back pressure in there. Basically, this is, Piscina will tell you when its queue is full, when its queue is empty, what you can, some of the things that you can do with it there, just for monitoring how much load you're throwing into it. And you can actively monitor to see what your performance of the queue is doing, your wait times, your execution times, that kind of thing. So you can actually tune the performance of Piscina as you're using it. So let's go through some other examples here. So the repo itself has quite a few examples that are in here. We have ones that are using ES module. There's one in here that's using an API, a native add-on for implementing the Piscina worker. And with this, it really just comes down to, we're pulling up the example index, which imports the native add-on. So here the worker is running, but the actual worker itself is all native C++ code that's running. So we have examples of the multiple workers. I mentioned this. So when you create an instance of Piscina, right? Typically, you would tell it which worker you want it to run. With this capability here, instead of attaching the worker implementation to the Piscina instance itself, you attach it to the task. So every task can have a separate worker JS file. So if you need to have multiple things that are going on, it'll still work. All right. Again, the API here is is intended to be as simple as possible. One of the things that is one of the advanced features in Piscina is the ability to provide your own task queue implementation. So the typical task queue, the default one that's in Piscina, is a first in, first out. As you add new tasks to it, whenever a worker becomes available, it'll just pull the next one off. In this particular case, with this example, we've created a priority task queue that allows you to specify a priority per task. And when the task queue selects the next item off, it'll look at the priority instead. So it's very flexible. It's not difficult at all to configure Piscina to use that. You have the task queue option on the Piscina constructor. You tell it which task queue you want to use, and all that does is implement a very simple API push, remove, shift for selecting or adding tasks to that queue. There is a module called Piscina Priority Queue that is out there that implements this particular example for you. Another example here, if you want to use Piscina with a server, for instance, so something like like Fastify, we actually created a Fastify plugin called Fastify Piscina that integrates Fastify with the Fastify server, so that when you register it, like I said, you should only have one version of Piscina, one instance of Piscina running per process. So when you're when you use this plugin, it registers that and just makes the Piscina available to all of your routes that are in the Fastify app. So here, once we've registered and we've told it which worker we want, we told it how many tasks per worker we want to be able to do. We give it an idle timeout, which the idle timeout is how long you want an inactive worker to be kept alive. And then from there on, we can just say fastify.run task, and it'll go off and complete the task. Now here, I'm not passing in any arguments, but we absolutely could. Now this is not, we're not going to do the actual I/O of reading the request or writing the response from within the worker. We would still do that within the main node event loop thread. But if there's any other tasks that we want to do, this is where we would, in that run task is where we would perform that. Now, and I'm going through this rather quickly because I want to make sure I have time to get into this example. So we have, just want to be able to show some of the benefit of using Piscina. So we have this example of doing React server-side rendering, which has always been rather slow. All right, so let's pull this up. Okay, we have two examples of the server, and the pooled and unpooled. The pooled version uses Piscina to go off and do the rendering, the React server-side rendering. Unpooled just renders the components directly, and we're using a pretty standard React server-side rendering model. All right, we're going to declare a route. We're going to give it some a template to do. It's going to render that template on every request. All right, so we are using AutoCannon, which is a benchmarking tool that Matteo created. So let me start the server. We're going to do the unpooled version first. Again, this is just using without the Piscina. And let's throw some load at it. So we're going to do AutoCannon, localhost 3000. I'm going to run a little bit of load, about 10 seconds worth at that on that server. What we're going to find in this particular example, not using Piscina, our average request per second is right around 3,400. It's not great. It's not terrible, but it's not that good either. So let's switch over to Piscina, the Piscina example, and see where we get. Again, in the Piscina example, it's doing the exact same thing, except it's doing the rendering itself in the event on the worker thread off the main node event loop. So we're going to start that one, run back over here, and let's run AutoCannon again. Let's see where we get. All right, what we see here, if we look at the same number, we see that we've essentially doubled the request per second just by taking that compute intensive workload and moving it off to the worker threads. Our latency is down. Our latency per request is down. If you look at the average, we've cut that in half, and we've doubled our requests per second. You can see here, we were able to do, with unpooled 32,000 requests in 10 seconds, and with Piscina, 62,000 requests in 10 seconds. Again, all we've done is moved that workload into the into Piscina. So how did we do it? We're using Fastify Piscina, the plugin. Whenever we get a request, we're telling it run task. We're passing in the arguments. If we go and look at the worker, we can see all that's doing is generating the React component, taking the inputs. And so every time we receive a request, that's just happening in a separate thread. Within Piscina, what's happening is every single time we get a request, that's going into the task queue. The task queue, where it'll sit in the task queue until there's an available worker. If necessary, Piscina will scale up the number of worker threads that are available. Here, we're specifically specifying that we have a minimum and a maximum that are exactly the same. So we're just going to say there are 6 worker threads on this particular machine I'm benchmarking on. There are 4 cores available. So we've gone 1.5 times the number of cores. And those, as those requests come in, they sit there and wait until a worker is available. The worker processes it, returns it, resolves the promise. Once the promise is resolved, the Fastify request gets completed. If we look down here at the bottom, we can see the example of we're monitoring what the wait time and the wait time for mean, the max. It's actually we use an internal histogram for checking this, how long a task was waiting in that queue before it was picked up, which you can tune based on the number of workers that you have available. We also can say what is the mean, max, and just general histogram of all of the run times for the workers. So you can see exactly how long your workers are taking to run. And again, here very soon, we're going to have the ability also to track how efficiently you're using your workers using Trevor Norris's new event loop utilization metric that he introduced yesterday. So overall, here the lesson should be fairly clear. When we are doing synchronous compute intensive tasks, Piscina can have a significant performance improvement. However, what if we're not doing something that is compute intensive? So SCrypt is it's a cryptographic hashing function that Node implements. It's designed to be CPU intensive. But Node already has SCrypt implemented asynchronously just by default. So you can do synchronous SCrypt, you can do asynchronous SCrypt, and typically folks would use the asynchronous method just through the crypto API. So it's something that has already been optimized for async in Node, regardless of using worker threads or not. So in this particular example, we have a few different options. We're going to run it pooled, unpooled, which is pooled the asynchronous version of SCrypt, and then we're going to have it unpooled, so not using Piscina with the asynchronous, and we have the pooled sync and unpooled sync. So let's go in and see where that gets us. All right, so let's go back to the examples here. All right. So if I run the, let's say, unpooled sync. Memory limit exceeded. I'm running out of memory on this machine, but it still gives you an idea there where you're seeing that the there's event loop delay right in here. It is fairly high. Let's run the pooled comparison and see where we end up with. By the way, this particular error is from SCrypt itself. It's a very resource-intensive operation. Okay, so if we ignore the errors there for a second, what we see here on the event loop delay when we run this with the Piscina pooled version, we essentially cut our event loop delay in half, running the exact same operations, the exact same times. But like I said, SCrypt has already been optimized for async within Node. So let's see what happens when we run the unpooled asynchronous version. We see that the event loop delay on the version that's not using Piscina is actually pretty low. That's because the SCrypt operation is already running off the main Node event loop. It's not blocking. It's still resource intensive, but it's not blocking. And if we run the pooled version of that, we'll see that there really is no change to the event loop blocking that's happening. So in this particular case, the version that of SCrypt that is async, that's already optimized for asynchronous activity within Node, has no benefit from being pushed over into the worker threads into Piscina. But the synchronous version, the one that is compute intensive that blocks the event loop, does see a significant performance improvement. So given that, we basically just answer the question, which types of workloads are workers and the worker pool model, what type of workload is it optimized for? And it really comes down to anything that is compute intensive that blocks the event loop, cryptographic operations that are not that cannot be performed off the event main event loop, server-side rendering, those kinds of things. Anything that is I/O based, that is particularly asynchronous I/O based, you're really not going to see much performance benefit out of using Piscina or worker threads in general. There are some exceptions to that that we don't really have time to get into now. But for as a general rule, that's where we're at. All right. So looking at a few of the other examples, I want to make sure we have time, at least some time for questions in here. Some of these examples, you should definitely explore for yourself. With stream-in, here we take a CSV file that has around 10,000 entries. And running the example, you can tell it how many of those entries you want to process at a time. What happens is the script will convert those into individual lines of CSV into individual JSON objects. Every single line is passed to Piscina as a task, processed. Piscina will do a little bit of work on it and then give the answer back. With this particular test, this example, you can experiment with how quickly Piscina is able to get through all of those tasks, based on whichever settings you give it. So I can run a quick example of that. All right, let's go to stream in. All right, so with this particular one, let's say the default of about 100. So as it's going through here, it's processing 100 of those items at a time. When it completes, we're seeing that it's taking about 979 milliseconds to get through the entire. And tasks are waiting an average of about 1.39 milliseconds to complete. If we bump this up to 1,000, right, we can see the impact on the actual runtime and how long tasks are taking to run. Let's do the whole 10,000 at once, or it's actually 20,000 entries in here. You can see that as you bump up the number of entries, the mean wait time for tasks sitting in the queue increases. That is just latency on completing those requests. So as we tune the number of workers that are available, the number of items that we're pushing into the queue at any given time, we can tune the performance of the worker queue itself. All right, so that's okay. So we have about 20,000 items. Let's do all this all at once. We can see that it blows out the time for completion quite a bit, and the mean wait time goes up. And if we were looking at the memory, then we could see that it was using quite a bit more memory. All right, so that's the example. That's the quick version. Let me switch back over to slides here. All right. So with that, that's the short version of Piscina. We're always happy to have more contributions, and if there's time for questions, let's have it.
Okay, thank you so much, James. And you can see your enthusiasm for this topic. You just you just wanted to keep going, and that's great. I've got one question that I'm going to cheekily ask, because we need to keep it quick, I'm afraid. But Bjorn has asked, he saw a tweet from Matteo a while back about React.js rendering in worker threads. Did you experiment further with it, and what are your current ideas?
I have not experimented much further beyond the example, just to kind of prove the point. There is quite a bit there that can be done. The challenge is really how the rendering occurs. If you look at the example, we're basically just doing it all at once. There's no streaming model for the rendering. There is a way, and I have another project that allows you to stream data back and forth between the main node process and a worker thread over a message port. And I'm working on the performance of that. But it might be a way for us to get even better performance out of the rendering. But it's just theoretical right now.
Okay, well, thank you ever so much. Great talk, great topic. So please do stick around, because after this word from IBM, we'll be joining Luca Holmquist, who'll be talking to us about serverless with the chance of cloud events. Back in 5.
Hi, my name is Joe Seppi, and I am an open source engineer and advocate at IBM. IBM has never avoided taking on big challenges. At IBM, we are privileged to drive impact at scale. We take on challenges that transform our clients, impact people's lives, and innovate for future generations as we strive to effect systemic societal change. Over the course of our 109-year history, the evidence has become clear that scaled change is best achieved through the focused deployment of technology, and especially tech for good. Call for Code, a program created by David Clark Cause and supported by founding partner IBM and charitable partner the United Nations Human Rights Entity, invites developers and problem solvers to build solutions that take on societal issues. Together with the Linux Foundation, we support the deployment of open source solutions around the world. Call for Code has a proven record of successful global programs that for 3 years have been addressing some of the most pressing challenges of our time, including COVID-19, climate change, and natural disasters. Call for Code has grown to include an impressive ecosystem of technology and humanitarian experts and more than 400,000 developers across 179 nations. I'm going to turn it over to my colleague now to share with you a new Call for Code initiative.
As this program has illustrated, when we combine technology and talent, we have the power to drive meaningful change. And as 2020 has reminded us time and time again, our world needs change. Our survival requires it. I have the great fortune of leading the hybrid cloud and edge ecosystems at IBM. I also have a great responsibility as a leader within IBM's Black community, a community that sprang into action following the murders of George Floyd, Ahmaud Arbery, Breonna Taylor, and too many others, to demand and enact change. Call for Code inspired IBMers of all races and backgrounds and job functions to think about the role technology could play in driving progress towards a more inclusive, equal, and just world. We recognize technology alone cannot fix hundreds of years of racial injustice and inequality, but when you put it in the hands of the Black community and their allies, technology can begin to bridge the gap. The outcome has been nothing short of astounding. The outcome has given me hope. The outcome is a collection of open source solutions developers and problem solvers across IBM and Red Hat have created in less than 3 months. Solutions born out of a need to turn this critical moment in our history into a sustaining movement. IBM provides the tech, but in keeping with the principles of Call for Code, it takes an ecosystem to scale change. With that, I am honored to announce Call for Code for Racial Justice. Call for Code for Racial Justice encourages the adoption, incubation, and evolution of open source projects to drive progress in 3 key areas. First, police and judicial reform and accountability. 2, diverse representation. And 3, policy and legislation reform. We will be launching starter kits for the initial technology solutions and will be releasing additional solutions over time. Your role, to the developers first, you have the skill set and the ingenuity to make a difference. Contribute to or use our open source projects once they're available. To the organizations and enterprises, you have the responsibility to make a difference to your employees and to the world. We hope you will commit to the cause to leverage technology to drive progress in combating systemic racism. And from IBM, you have our commitment to continue to listen, learn, and use technology ethically and responsibly.
Hello and welcome back. And for our last speaker today, we have Luke Holmquist. Luke is a senior software engineer at Red Hat, where he helps lead the cloud and enterprise group for the Node.js runtime team. Closing the conference on a high note, I give you Luke Holmquist and Serverless with a chance of cloud events.
Hello, thanks, Katie. All right, just looking at that picture from my slide, I realized that's probably like 15 years old. So this is what I look like now. Right, yeah. So thanks everybody for coming to my talk. It's the last one of the day, I believe, before the closing ceremonies. Serverless with a chance of cloud events. I just want to say that I'm pretty excited to be back to NodeConf, even though it is remote. This is my third year now, I think. It's kind of been always one of my favorites to attend and stuff, and I've always met a lot of kind of great people at the Red Hat booth when I'm doing booth duty, and I just want to give a shout out to the person that I met on the bus last year on the way down after they asked me to watch the luggage real quick. So shout out to that person if you're still watching. All right, anyway, let's just get started, I guess. Right, yeah. So just a little introduction here. My name is Luke Holmquist, senior software engineer at Red Hat. My main focus is on the NodeShift project, and that project kind of aims to make Node.js developer kind of applications work better on OpenShift and Kubernetes. I'm also a maintainer of the Cloud Events JS SDK, which we're going to talk about in a few minutes. On Twitter, you can find me at Sienna Luke. Also a huge Fish fan, the band Fish. And just another fun fact, I'm also the current title holder of a Star Wars trivia contest at my local library. So I don't have a trophy or anything, but it's one of my accolades, I guess. And for those wondering, the winning question was, what was the number on Princess Leia's cell in the original Star Wars? So if you stick around towards the end of the presentation, I will give you the answer to that, unless you Google it now. So whatever. All right, so let's just get in here too. And since we're all remote, I just kind of wanted to show you where I was in the world. So I'm located in upstate New York. If you're not a New Yorker, this picture probably will make 0 sense. But if you are watching this and you are from New York, you guys know what I'm talking about. So anyway. All right, anyway, so yeah, let's just jump right in here. So as the title said, we're going to talk about cloud events. What are these things called cloud events, right? So cloud events is a specification for describing event data in a common way. Cloud events seek to dramatically simplify event declaration and delivery across different services and platforms, especially when we're talking about events that could be triggering serverless functions and stuff. So, but before we kind of get into the details of cloud events and the spec and what they are, let's kind of do a little history lesson and kind of go back. Let's get our DeLorean here, or whatever time machine you like to use. A little trip back in time, like 47 years ago, it feels like, to the year 2017. So back then, today there's people who are always talking about serverless, and it's a huge thing, and they're talking about serverless functions and everything. But back then, 2017, it was a relatively new space. So it was just sort of starting to become meme-worthy back then. So the Cloud Native Computing Foundation, or the CNCF, which many folks probably have heard of, they have just a couple projects that they work on, as this slide shows. They created a serverless working group to see if, was there anything that maybe the CNCF should get involved in the serverless space, just check it out, see what was there, and see what's what. So what they found there was that there was many serverless solutions, a lot of these different platforms and stuff, but there was no real interoperability between any of these platforms. So you couldn't just move, if you had functions running as a service or something, you couldn't just move one function from one platform to another. And that was kind of a real pain for the developers and stuff. And that problem, really, there was a real good way of tackling that problem, because in order to do that, you'd have to include input from multiple vendors, and all those vendors are possibly have many differing points of view. So things can get political really quick. So they decided, is there some sort of low-hanging fruit that they could do? Was there some sort of common theme between the solutions that they could use as a starting point? And what they found there was that a lot of the workloads in serverless were all event-based, right? So events are sent from some service or something. They're usually routed, probably some middleware, possibly more than once. They can take multiple hops and that kind of stuff. And it's possibly over many different protocols as well. And it's the job of these middlewares to route the events to the appropriate places. And those things, they don't really care what the message is that you're sending, right? It doesn't really care about the business logic. It needs to know enough information to route to those things properly. Like, should it go to an HTTP protocol or should it go through NATs or something like that? So they thought, maybe this is a good space. This eventing space is maybe the low-hanging fruit that they could start and look to see if maybe there's some sort of commonality between the events from these different platforms. So the goal here, it wasn't to create a new, not another event format, because those things have been tried before with little to no success here. But really, it was to define common metadata for the events and where this metadata should appear in the message that is being sent. So really, it's a pretty simple spec. It's common metadata, it's a common location, just enough to help with the routing. So very simple spec with very simple goals and stuff. So in December of 2017, Cloud Events is born. In October of 2019, so just about a year ago, it became a CNCF incubator project, and version 1 of the spec was released. So while this spec actually discusses a lot of different transfer protocols like MQTT, HTTP, Kafka, NATs, as well as some different coding way you can encode events, like using JSON or Avro and stuff like that. In the next few slides that we go through, I'm going to be looking specifically at how Cloud Events relate to HTTP. And also in how they're encoded in JSON. So just kind of as an FYI, as we go through these next few slides, it's going to be very HTTP based, JSON based. So let's take a quick look at what some of this metadata is that they came up with. And you'll notice that there's some asterisks on some of these and on 4, and those are what are the required fields. So all events have to have these ones with the asterisks on them. So if we take a look at these, so we have a type, and this type is really defining what kind of event, what type of event this is. It could be a create event, a delete event, some other type that somebody wants to do, and then also the spec version is also required. So in this case, it would be version 1.0 or something like that. Source here is where the event came from, and if you wanted to make things a little bit more granular on where things came from, then that's where the subject field would come into play. And then you also have an ID, which I think is somewhat self-explanatory, but it's just a unique identifier. It's useful for deduping. So if you have multiple events being sent, or the same event being sent multiple times, then you can kind of see that if you've already gotten it, and do some deduplication there. There's a time field just saying when the event was set. Also data content type and schema. If you want to change the specifically say this is the kind of data that we're sending, and if you want to validate your event and your data based on some sort of schema and that kind of thing. But those ones aren't required here. There's also some extensions that a user can define if they need a little bit more metadata that's not in the spec. They can define some extensions, but it's still defined in the same place that these other pieces of metadata are. And if there are extensions that people and other users are using consistently, and there's a common thread between them, then at some point maybe those will become part of the specification. I also put adapters here. Now adapters isn't really part of the spec here, but I just wanted to kind of call it out because in our spec repo there's docs around these adapters for some popular platforms like S3, GitLab, and GitHub. So for example, GitHub, the webhooks for GitHub, they don't actually send cloud events yet. So the team has worked to define some metadata in these webhooks saying, hey, if you have these things, they map to these fields in a cloud event. So if you wanted to convert a GitHub webhook to a cloud event, you could use these documents and transform them, and you can transform it in a predictable way. Right. So talking about the metadata formats, there's 2 at the moment that you can choose from. One is called binary, and this is sort of the preferred way that we think. And the reason why is because it's sort of additive. So basically, in the binary format, it only adds header. Oh, and we're talking about HTTP here. So it really only adds headers to the HTTP request. So not really changing the request too much. So if you have a request that's being sent to some middleware, for instance, and that middleware doesn't know about cloud events, it's not going to break anything. It's still going to go through. It just will ignore those headers. And then, at some point in the future, if that middleware gets updated to know about cloud events, then things will start working again. Or not working again. They'll just start working with cloud events as well, because now it knows about it. And the other one is structured. So for those folks who, they haven't done anything yet, they don't have any defined format currently, and they're looking for just some guidance or something on the way things should be structured. We have this other structured format. All right, so let's take just a kind of a quick look at maybe a raw HTTP request here, real quick. So here we have just an HTTP request, post request. It should be somewhat familiar to folks if they've ever kind of looked at requests in like the Chrome debugger or anything like that. Here, we're sending a content type of application JSON, and the body payload is we have an action called create thing and an item 2187 here. So we can actually add. So if we add in and make it a cloud event message, all we have to do is add in these headers. And for binary here, the headers have this CE dash prefix. So here we have the four pieces of metadata that are required here. So we have our spec version, we have our type. Here it's coming from this nodeshift.create, or it's a create type from this nodeshift org or wherever it is. The source is coming from this nodeshift.dev site, and then an ID. Just it's in real life it would be randomly generated, but here we're using just 1, 2, 3, 4, 5, 6 as an example. And then just to show what the structure would look like here, so the headers are very similar except for the content type here. We're actually using this special application cloud events plus JSON content type, but instead of putting the metadata into the headers here, we're putting it into the request body. So we're just adding those fields that were from the binary to the request body, and the data is now in the data property, kind of one level down inside that message. And if you are an astute observer, the number that was in the item thing is actually the answer to the Star Wars question that I posed earlier. So yeah, also it's the Stormtrooper designation for Finn in Force Awakens, in case anybody else was as nerdy as I am with that. So anyway, so these are kind of what the formats look like in kind of a raw HTTP setting here. But we don't really use this way, right? We use SDKs and stuff. So here we'll check out some of what the SDK is all about. So the spec defines some guidelines for what an SDK has to do, right? So it has to compose event. To be able to compose an event, it has to be able to take that event and based on some sort of transport method, we have to encode it correctly, and so we can send it. And then any events that come in, we need to be able to decode those into event based on HTTP or those different transport methods and stuff like that. And in just a couple of minutes, we'll see kind of examples of what these are. And just as a kind of an FYI for folks there who, I know this is a NodeConf, so we're going to look at the JavaScript SDK, but we had in all the kind of, I don't want to say major languages, but in all the sort of the usual suspects of languages, there are SDKs. They all vary with the degrees of maturity, but those basic principles we just kind of talked about are all in there. And stuff. So yeah, so let's take a look at the JavaScript one because we are at a NodeConf. Right, so very easy to install, npm install cloud events. It has gone through some major revisions in the last 6 months. It was rewritten totally in TypeScript over the last few months. We're currently on version 3.2.0. So what can this SDK do, right? Like we said before, it can represent a cloud event in memory. It can serialize and deserialize cloud events in these different formats, and it can send and receive cloud events, these different protocols and that thing. And at the moment, for the JavaScript one, only HTTP is supported, but we're in talks right now to support. I think MQTT might be the one that's up next. And then next week, I think we're going to release the next major version, which is 4.0. This removes a lot of kind of the old ways of the way you would receive and you would emit events. But the examples that I'm going to show have all the new APIs, and those are actually currently available in the 3.2.0 release. So if you are interested in using it now, you don't actually have to wait till the 4.0 release come out. All right. So okay, let's see how we create a cloud event here. And I realized I made the animation a little slow. So anyway, yeah, right. So you require just like a normal thing. You require the cloud events. Here we're going to use the cloud event class. Here we in order to create a cloud event, we just give it some options. Here we're putting the type and the source in, and giving it some data. And then when we console, we can console log out. There's a two JSON method on the cloud event here, so it'll print out in the correct format over on the side. Because we hide some of the data fields, so we can't just do a regular console log of just that CE variable. So you could see here what it. We have the ID, which gets added. That will be a UID that gets generated. Here we have the type and the source, which is what we passed in. The spec version will get populated by default because there is really only one version. The time will get populated by default based on when you create it, and the data gets added. So really, a cloud event, the event itself is really only an object, and you could just create that event manually if you wanted to, but then you'd have to worry about the formatting and all that stuff. So using kind of this constructor is a good way to do that. All right. So now if you've created a cloud event and you want to add maybe an extension to it. So whenever we create a cloud event, they're always immutable. So we freeze them after they're created. So if you wanted to add anything to it, like an extension in this case, there's a clone with method. So you just say, I want to clone it with this particular property and this value. And then that will return a new cloud event for you. And if we log that out, we can see that, and I've kind of bolded, maybe, I don't know, hopefully it'll come through, that the extension 1 here was added to the cloud event. So now we've created a cloud event. Let's talk a little bit about how we actually send them out and emit them. So here we're just gonna build upon the previous slide, just so we don't have to list all those options when we're creating the cloud event here. So in this case, we're requiring here the cloud event class, but then we're also requiring this HTTP object. We create our cloud event like normal, and then to put it in the binary format, we just say this HTTP.binary method, and we give it the cloud event, and that gives us our message. So when we log that message out, here we can see that it gives us these headers and the body, in the correct formats, and just as kind of a just for completeness here is what it would look like. What it would look like for the structured mode. So it's the same kind of thing. It's just .structured instead of .binary for the call. And here, it creates the header of the application cloud events plus JSON, and also gives us the body because that's all the metadata is stored in the body of the request here. Now we haven't actually sent, up to this point, haven't actually sent any messages yet with cloud events. So we're going to need to use an Axios or a library like Axios here. So again, building on the previous slide, we're going to take that message. We're going to, for the data, we're going to say, okay, we want the message body and we want the message headers, and put it in there. This URL just points to some random localhost cloud event endpoint, and it's a post method here. And then we're going to, since it's Axios, it returns a promise, so we can do that then, or we can do an async await if we want to. We'll log out the response data, and we're going to pretend that it returns, this object that has key and event received. If anybody has ever used the previous versions of the SDK, they might know that we would emit and we would have Axios built in, and it would do all of that for you. But what we realized when we were talking about protocols that we want to add next, we realized that it was going to start to clutter up the module itself. So, MQTT is one of the things we wanted to add, and that module is very, very large. The MQTT protocol library is very, very large. So we didn't want to kind of bloat the module if you were going to only use HTTP. So we figured the module should really only be the thing that formats your message and formats your events, and then you can use any transfer protocol you want, library, to then send those things out. So if you wanted to use requests, for instance, even though it's deprecated, you could use that instead of Axios. So just a little sort of tangent there on kind of why that was like that. Right. So like I said, this sends out the message. So now we can actually see what this receiver would look like here. So here we're using just Express to create create an API. I'm kind of doing glossing over a few things. Like I'm not, I haven't added the body parser because you would need that to get the request, the body for the request. So I'm leaving a few things out here just for in terms of slide real estate. But anyway, so the request would come in. You would use this HTTP method, this toEvent method, with the give it the request headers, give it the request body, and then when we log that out, that should show us that was, yes, that's the event that we saw previously that we had just sent. And then here we're just sending out that event received key, just so we have a fully flowing example here. All right. So yeah, so I think we're about at 20 minutes here or so. Yeah, so if you want, and it's just kind of a quick overview. If you want to learn more, there's a whole bunch of links here. You can check out the Cloud Events IO website. I have the GitHub org for the Cloud Events. There's the spec repo, the specific JS repo here. If you want to get involved, we have weekly calls on Thursday at 12 p.m. Eastern Standard Time, New York time, I guess, on Slack. There's a Slack channel here. And then right after those calls, every 2 weeks or so, we have the actual SDK call. So if there's anything specific to the SDK, we'll have those calls as well. I also put a link here to this Cloud Events Async API talk, which a lot of this kind of the background information that I talked about was based on. So if you want to have a little bit more in depth on the background information, that is probably a good video to watch. And just a link to the code example, actual really functioning code example that I kind of just showed those snippets of there. And then also a link to the NodeShift project if you're interested in what we're doing over there as well, just as a shameless plug. Also, if you're in the US, make sure to go vote today. But with that was the end of the talk, and I think we have probably a little bit of time for questions.
Okay. Thanks, Luke. That was excellent. I've got a couple of questions for you, but if anybody else wants to add any questions, please use Slido. Add your questions in there, and we can go through them as they come in. So to start off, could you tell me what projects are using Cloud Events today?
Right. Yeah. So Knative is probably one of the bigger ones that have settled on using Cloud Events from the very start. Also on the website, and I should probably have the website up, but there's a whole list of other projects that are using it as well. So it's quite a lot of a good amount at the moment, even though for such a young spec, there's a lot of interest so far, which is very cool.
Cool. And are any vendors supporting the Cloud Events effort?
Right. Yeah. So Red Hat, that's where I'm from. IBM, Microsoft, Google. So kind of all those the big names in the serverless space. They're all part of. We're all part of drafting the spec, and they all have interests and are participating in creating all these SDKs and stuff. Yeah. So yeah. So we have a good community so far around it.
Excellent. There are no more questions, so I am going to leave it at that. Thank you ever so much, Luke. It was a fun. Oh, hang on. One coming in at the last minute.
Another question.
Yeah.
All right.
What would so Nagitor, what would be the easiest way to try out for a toy project?
I would go and check out the. If you're interested in the JavaScript SDK, I would go and check out our GitHub repo. There's some examples in the repo that shows some TypeScript examples as well as just regular Node examples there. Yeah, and you don't need any kind of serverless platform. If you want to try it just locally, you can run all those examples locally. There's even a really cool kind of weather app that uses some WebSockets as well, where it sends the events back and forth, and you can put in your zip code or whatever, and it'll go to a weather service and give you the weather. So that's sort of more of a real life example there. Yep.
Nice, thank you. Okay, just giving it a second in case somebody else is typing away. Nope, nothing coming up. Thank you, Luke. That was a great conference closing talk. Okay. So thank you, the audience, for being here today. And a massive thank you to all our speakers. If you've missed anything today or yesterday, you can go to the NearForm YouTube site where you'll be able to catch all the talks. If you're lucky enough to be going to one of the workshops over the next 3 days, enjoy. If you have a place and you're registered for it and you can't go for whatever reason, please unregister. We have a big waiting list, so if you can't make it and you can give somebody else a chance to go, that would be amazing. I've missed seeing you all in person. I really have, but I have to admit this has been an amazing conference. So thank you so much to Matteo and James from NearForm for the speaker selection, to Leanne, Sean, Kalina, and Craig, and NearForm and the NearForm marketing team, to Dan and Chris and the team from Flux Broadcasting, and of course to our NodeConf Remote sponsors. So that's NearForm, Microsoft, Bloomberg, Red Hat, and IBM. That's all for me. If you live in a country where there happens to be an election today and you haven't yet been out to vote, and you can, please do go out and vote. What Luke said, look after yourselves and stay safe. And over to Matteo.
Hi, Katie. Thank you for passing me for giving me a few last words at the end of the conference. It has been a fantastic 2 days. We hope that we have been able to reproduce some part of the feeling that we had at the real NodeConf. Of course, we miss seeing you all together, but hopefully there will be a lot more people. There was a lot more people here, so I'm really, really pleased that we got such a big crowd connected in and watch our talks. So I'm really, really happy. As Katie said, we have a bunch of workshop the rest of this week. So please attend them. If you didn't attend, if you don't have a spot and you really want to join us, please let us know and we might be able to. So ping me. Hopefully, my DMs are open on Twitter, so you got a chance to follow me on Twitter. Here we go. And if you really want to participate in one of it's sold out, we'll try to see what we can do. There will be probably some other run up on those. So if you want to do them, we'll try to see what we can do. Anyway, just to finish, I can't steal the flag, and I can't have a closing party. So hopefully, if we were in Ireland at this point in time, we will be having a pint all together in Kilkenny and relaxing after a fantastic 2 days or 3 days even conference. It's not there. I hope next year we'll be able to meet each other in person. Maybe yes, maybe no. We'll see. I would just want to reiterate what I said at the very beginning, which was that, NodeConf really changed my life. So I hope to keep up the torch until it lasts. So thank you all for listening and stay safe. Bye. And keep using Node.js.